Hello. Hello. I guess this is the right meeting. It is my mistake. I chose to go to a wrong meeting room. And that's the reason why, all of you were in the other room waiting for the host. And it was just me and Mark Myers talking one-on-one, apparently, in that other room, which doesn't make sense. But Mark and I both have hung up, and we are now back into this meeting in which I need to unmute all of you so that you can talk. And that was silly of me to just, go away from this meeting, which, I was in the wrong meeting primarily. That's the problem. That was the problem. So I will.
So was that the reason why I was not getting in?
Exactly. That was the reason. So give me a second. I'm just turning my head towards you. I am going to make sure that I am hiding all the. Yeah. So my screen should be visible to you, I guess. Right. Yes.
Yes.
Hi. Do you see me?
Yes.
Okay, good. And you can hear me. I can hear you. That is good. I am sorry. I chose the wrong meeting room. I was talking to Mark and I assumed that I'm in the right one. That was not a good thing. So this is the meeting for the Cloud Bootcamp, which I think is also written down, but my mistake, I just did not pay enough attention. So yeah, I am sorry. So we are now on the same page. And I just want to recap that the meeting is this one that is on the notebook. That's the meeting link. I should maybe highlight in red color for myself. And so that, bad color. So that meeting is the number that I think we should be using. And I chose the wrong meeting. Sorry about that. Now we are in the right spot. And let us do a quick recap and proceed.
Broken.
Okay. So I think some of you have had trouble in accessing content available on this site, on the Cloud Genius site in the dashboard section. I think at least one person had trouble. And so we were able to work around that problem by using another method, like using a personal email as opposed to school account. And so that is happening probably because of a fact that some kind of a Office 365 connection issue, or I don't know what, but we'll do diagnosis later. For now, I think Mukesh has access, and I just want to hear that confirmation. I think he wrote that he has access.
Yes, I do.
Good. So you have access. That is good.
Yeah.
Should we see all three sections or only
just one? Just one. I will enable. It takes me time to go do a backend database modification to enable these accesses for you. So I will do that. But right now, I think this one should be visible right away, right? Yes, this, as you know, all of you know already, this is a reference material area. So where we store our reference content, which we refer to as we go along, as we need to, and it is available to you during the program. And you should also read through as you get time. And you should also notice that on this section, the last time we met, all the whiteboard notes are shared in this location. You should be able to see that. We have a new person join into the program. Her name is Marjorie Blanco. She will be joining starting Saturday. And we are recording, so she will have access to that material as well. And I think that makes us a group of 7 + 1. Now today we will just quickly recap what we discussed and then describe some very specific things. We will begin doing some hands-on work today, for which I just want to make sure that you have this machine with you. This virtual machine should be running, and you should be able to test it out that it runs. So like a simple command showing you the file listing, you should be able to see that the machine runs, that this terminal application that you see on the left side of the screen, that left side, you should be able to see that this application that I have running, it is accessible in this location called terminal. That should actually run correctly. And as long as it opens up correctly, it will work just fine. I just want to make sure that each and every one of us is able to open and see this brown, black, or whatever colored window that is. And you should be able to see some things there. This is the Unix command line. It is similar in concept to Windows PowerShell. Conceptually, those are Windows people. This is the PowerShell for Linux, or whatever you can call it. This is the terminal. This is ancient product, probably 30, 40 years old. People have been using this. I am in love with this, and you will probably either love it or hate me for that. but this is the primary tool that we have. So we will use this quite a bit, starting today, right now. But before we jump into an exercise, I want to just quickly recap what we discussed the last time, close on that topic. I think we ran out of time the other day on that particular topic we were talking about, which was the definition itself. We covered a couple of things, but we did miss one key important definition, which is this NIST definition that we were talking about the other day, which is, here's the definition itself that you saw. And the thing that we did cover, which is we covered the idea of, what are the three service models, meaning infrastructure as a service, platform as a service, and software as a service. And also covered 5 key characteristics, which you probably recall from the definition, but these are, the idea is, let's go read. No need to memorize. Let's go read the 5 characteristics. And those are here: broad network access, on-demand self-service, resource pooling, sharing, and elasticity of growing, shrinking, both ways, number as well as size, and measurement of service. So that's the 5 characteristics that we saw. And then the thing that we did not discuss was this concept of deployment models. Like, there are 4 models described in the definition, and there can be more, but this is just what the definition says. So understanding the definition part, I'm going to make a new tab here, call it, cloud technologies for day number 2. And in that section, I will now start taking notes for today. And we are just using this as our notebook as we write things, as our whiteboard. And so we have this 4 deployment models. And those models are, public cloud, private cloud, and something of a mix called hybrid cloud. And then there is another term defined by the definition, which is community cloud. And the definition goes in defining this as something that is specific to a community, but it is more like public, except limited to the community. So that's the definition that they have given. Hybrid can be a mixture of public and private. And I think these are intuitively very clear. Private cloud is inside the firewall in your building. And if it is virtual private cloud, it doesn't need to be inside your building. It can be outside your building and still be your private cloud. That's a possibility. In fact, we will go do tons of exercises ourselves in a virtual private cloud. We'll do that. And we will use the public cloud actually to create a virtually private area in our network, in our subnet, but it will be away from us, not inside our boundaries, physical boundaries. It will be away from our boundary. It will still be private, and therefore it will be a virtual private cloud. And public cloud is like Amazon, like Rackspace, like Azure, like all these players. So those players are public cloud. Anybody can just open up an account and use these services, and that's what a public cloud is. I think that should be simple. This you already know. Private cloud is something like, inside my boundaries, in the building, I set up a dedicated set of resources and use that as a cloud. And hybrid is a mixture. So hybrid, you can actually define a mixture of multiple public clouds. You can define it like that, or a mixture of public and private, both together. That could also be a definition. So you can basically define how and what you mean by private or public. And that's the key 4 deployment models that are defined in the definition. Here are the 4. And I think you understand this quickly from a top level perspective. And that's the extent that I want to discuss. But there is one key question that pops up, which is, when you're talking about private cloud and you're talking about a building, and that you own that building probably, or maybe you control it, it's in your boundary. And so it is kind of sort of very similar to a data center, right? How is that different from a data center? That's the question most people ask. So you tell us that private cloud is like in my boundary, within the firewall, and also on my campus. So how is it different from a data center, which is kind of sort of the same thing? Like, what's the difference? Anybody can attempt to answer. Do you want to answer the question if you know? How is this different? These guys. They look similar to me, very, very similar. Anybody wants to take a shot? Why are they different? Why is data center not a cloud?
I would say they're the same in that you can have a data center for your private and you can have a data center for public.
Yes, you could have, but why is that? Why do I not classify data center in the definition of cloud? Why is data center not a cloud? Let me emphatically say the data center per se does not make it a cloud. That's the comment I want to make a statement. It doesn't make it a cloud. Just the fact that it's a data center doesn't make itself a cloud, even though it may be private, doesn't become a cloud. Why? And that's the question. So the answer to that question actually boils down to the earlier part of the definition, which is right here. In our definition, we said there are 5 characteristics that are required. And these 5 are very, very simply that you need to have on-demand self-service. Now, in a data center, you typically go to the IT department, ask for some machines, and then they will take their own approval time, maybe a day, maybe 2 days, sometimes in larger companies, a couple of weeks, easy, right? And then you might get access to a machine. And then you run it, you run your app, and then IT basically manages it for you, and then you need more machines. You have to go through the approval process again. It is not really on demand. It takes time. And so if you want to mute yourself, it's a good idea if you want to mute. If you're causing noise or breathing into the microphone, maybe it's a good idea to mute yourself. I don't want to mute you. I want you to have control to mute or unmute yourself. So please unmute if you want to breathe into the microphone. Thank you. And so the concept of on-demand self-service is like, okay, I click a button and I get my resource. I don't have to wait for IT approval or some boss's approval. As long as I'm going to pay for it through my budget, even within the company, I need to have that ability to be able to get things on demand. Click a button, I get it. Click another button, I let it go. Run an API call, I get a machine. Run another API call to release the machine goes away. Those kind of on-demand characteristics are one of the fundamental characteristics that you need to have to call a data center a cloud or a private cloud. It needs to be on demand. It needs to be available to you within the company across the board, whether you are in, say, in Microsoft, so you are in Sammamish location or in Redmond location or Bellevue or some other location in Fargo. You need to be, as long as within your company, within your location, you need to be able to access those resources wherever you are, no matter whether you need to be inside the firewall, inside the logical boundary of the company. And that's another characteristics. If you cannot do that, that's not a cloud. It's a data center. It's not a private cloud. Another one, resource pooling. And this concept is where you are sharing resources between the marketing department, the sales department, the service department, the product development, testing, this and that. All of these people who are internal to the company are sharing resources from the same set of pooled resources. So you have a collection of things that you deploy in your data center. Are they shared among your team members or your company? If that's a characteristic you meet, yes, that's a required characteristic, and that's what is needed to make a data center into a cloud. And another one, elasticity. You know, we talked about getting a machine in the data center from an IT department takes a couple of days, couple of weeks, whatever it takes. That's possible, but it's very slow. It's not on demand. And it may or may not be elastic, as in it cannot infinitely grow. Cloud is theoretically infinite. Not in practice, but in theory, it is the illusion of infinity that what cloud tends to provide. So Azure, the names are even names that these companies use, like Azure. It kind of signals a large Azure colored ocean of resources, infinite. Think of this, another company that I was talking about just the other day. This company's name is DigitalOcean, and they call their machines droplets. So literally the illusion of infinity, droplets in the digital ocean. That's the branding that people go to the extent of claiming what they have just to create illusion. Now taking that same illusionary idea of what we have here, which is elasticity. So you should be able to give that illusion of infinity to your internal employees within the data center to call itself a private cloud. And one last thing is measurement. And that measurement has to happen, which is if you have a internal data center that you want to call private cloud, then you better meet those 5 characteristics: on-demand elastic, on-demand access, those 5 things. I keep forgetting that. So, but let me go there. Yeah, all these 5: on-demand, network access, resource pooling, elasticity, and last thing was measurement. That is, if marketing department is going to use your resources in that data center that you want to call a private cloud, you better bill the team from marketing. So the marketing people are using that resource. You better give them an internal cost center bill and let them pay for it. So that's how they can get to use your resource. And as long as these conditions are met, then you can call that data center a private cloud. Then essentially a data center becomes a private cloud. It can be classified as a private cloud provided you meet the other conditions that are defined to conclude that where is that thing? What did it disappear? Hold on, let me go there. Yeah. So these 5 characteristics have to be met. And if they are not met, it's not a cloud. Even though it may be a huge, gigantic data center within your company, it needs to function like this: on-demand API-based access without having to call IT department, grow and shrink. When I want to let go, I let go. I'm sharing resources with other people in the company, and I'm getting a bill. It may be funny money bill in the company, funny money, like cost accounting money, but it is still have to be paid for. It cannot be free. And it gives me the illusion of infinity. So these characteristics have to be met. And then I can call my data center a private cloud. I can assign that and let other people outside the company make it usable to them. It can even become a public cloud if I decide to do that for my company. So that's the kind of concept that I would like to call out from the deployment models perspective. Now, questions on this topic, if you have any, before we move on to the next concept of virtualization, and then we will start going deeper into the infrastructure as a service elements. We'll also go into all the components that build up towards delivering infrastructure services. We'll also briefly cover software as a service because it is kind of trivial and very simple. You already know it. And then we go hands-on with more platform as a service exercises to understand how do we take an application and run it on a platform without having to worry about. So we'll take an existing app and use an existing platform as a service and run it there and see how it works. And then we have another open source product which actually creates our own platform as a service and runs it on some infrastructure as a service. And we will create that. There is also an exercise for that. So we'll do those exercises as we go along in this cloud technology segment. So I'll take a few moments and ask you if you have any questions on the definition itself or any commentary that you want to say. Go ahead, please do that before we switch topics to virtualization, just quickly understanding that and then taking some examples.
Hey, Neela, just a quick question.
Yes.
This is David.
Yeah, hi.
Hey, so if you manage and you own those resources, those on-demand resources, whether it's yours, right? So what's the differentiation between it being private versus your managed resources being public?
So public literally means anybody in the public domain can, as long as they're going to pay for it, can make use of your services. Just like you can today go to Windows Azure. No, it's not called Windows Azure these days. It's just Azure. So you can go to Azure and get an account, put a credit card there and start using Azure services. You can do the same thing with other big cloud companies. Anybody who's on the internet can have a credit card. You can go and use it. As long as that condition is met, that is considered a public cloud. And you also have to meet the other conditions like these characteristics, like I mentioned. These 5 characteristics that we discussed, they have to be met. And then you deploy it the way you deploy. If you're giving access to public, it automatically becomes public cloud. If you're giving access to only a portion of a public or a community within the public domain, like certain types of people, then it becomes a community cloud for that community. For example, there is this Gov cloud. So all the federal employees have access to GovCloud, and you and I don't, because we are not. So that is a community defined by the fact that they are employees of the federal government. So you can call that is a community cloud. It's kind of sort of like public cloud, except not open for public, is limited to that community, government employees. So that's the definition of a community cloud. Now, public and private is very simple to understand. The key thing to understand here is that it needs to meet those characteristics of elasticity, on demand, pay as you go, get a bill, pay for the bill, let go of the resource, get the resource whenever you feel like, scale it, scale out, scale up, scale down. All of these conditions need to be met. Then that is a cloud. Now, if you limit it to the public domain, open it to public domain, that becomes a public cloud. Limit yourself to a private area within your company's firewall is a typical use case. That's a private cloud, right?
So, so the lockdown is basically like just a firewall lockdown to your private system.
Yes, in fact, a private cloud, let me draw another picture for you. So a private cloud be something like, I have this firewall boundary. Let's imagine this is the Boeing company, the Boeing company, like you cannot get in because you are not a Boeing employee. You cannot. And so those people who are Boeing employees are here. They are in the company physically present. Sometimes they are outside the company boundary, physically outside, but logically inside because they're VPN connected. And in that case, they are also in the company. So as long as they are logically in the company, they can access this large, gigantic structure, which happens to be their private cloud. And this is the audience is these employees of Boeing company, including this person who may be physically outside, traveling or home or Starbucks, wherever they are, as long as they are connected through VPN and are logically inside the boundary. So this guy logically is actually here. He may be physically outside, but you logically place yourself in the company when you connect through VPN. And in that case, all these people, this guy is a proxy, the logical proxy to this physical person. This guy is real. He is real. So those people can actually access that private cloud. It is designed to be used by people of employees of the company, and you and I who are outsiders cannot. So we are logged out. That's why it's called private. And it functions like a cloud, meaning it meets all those conditions, like these characteristics, 5 characteristics I mentioned. And as long as that happens, that's a private cloud. If they're not meeting those conditions, then it is not a cloud. It is still private, but not a cloud. It is a data center. It's a bunch of machines sitting around that you have to go and ask for, and somebody will give it to you if they decide to. You don't have that luxury of just clicking a button and get a machine and use it. And when you're done with it, just let it go and you don't have to pay for it. So that flexibility of on-demand access to shared pool of resources is missing in a data center typically. And if you provide that capability, then that data center automatically becomes a cloud. If you limit access to that data center to certain employees within the company, that remains a private cloud. If you open up doors and you decide that, you know what, I'm going to open my firewall and let everybody come on in, party. And as long as you pay, wherever you are, you can use my resource just fine. So here is my resource. And people from inside, people from outside, you and I, everybody can just put in a credit card and use that resource. That definition becomes the same cloud, converts into a public cloud, as long as it meets those conditions, these characteristics.
Right. So will DigitalOcean or Microsoft or Amazon, will they enable you to privatize and centralize that type of system?
Yeah, they do. Yeah. Not DigitalOcean. Don't count them as a full-fledged cloud. They're just a machine provider. They're not a full-fledged cloud according to this definition. However, Amazon, Google, Microsoft, all these guys provide you a full-fledged virtual private cloud. Virtual. So what they do actually is something like this. Let me draw another sheet of paper. Another sheet of paper like this. So imagine, actually, why imagine? Like, go there. Here is the Amazon's cloud. So we have an account, we logged in. Now in here, there are resources available. You can see that. There are compute resources available right there, compute and this and that. Let's focus just on compute to begin with. So this is the Elastic Compute Cloud. The name itself says it is Elastic Compute Cloud, which is shortened as EC2. So it is elastic by very nature. You can grow and shrink, make it big, make it small. And it is focused on compute. So it is, it has these three things that are important, which are compute resource, your storage resource, and network resource. Those three things they provide you primarily from a usage perspective, 1, 2, and 3. So that trifecta is what is provided in this cloud, EC2 cloud from Amazon, and it is publicly accessible, so anybody can get it. However, you and anybody else also can construct a virtual private cloud, private cloud out of the resources available from this public cloud known as Amazon EC2, or known as Google Cloud, or known as Azure Cloud, or Giant Cloud. All the big name companies already provide you a scenario where you can get virtual but private. And you can totally get that. In fact, that's the dominant way. That's the only way to begin with. By default, this is the only way today. If you open a new account with, say, Amazon or Microsoft or Google, this is the only way you can access cloud resources, is to carve out an area in their public cloud and call it your private cloud. That's the only way they give you by default. When I signed up, I think I had a different method. It did not exist. But I think I still have access to that other type. Let me just quickly show you what that means, which is more like DigitalOcean, because they are not giving you a virtual private cloud. So I'll just select this and see if I still have access to that and old generation. So all generations might have it. Let's go check. Older generation, hardware, let me pick this one and go configure. Oh no, yeah, they got rid of it for me also. So the only way, you used to have another scenario called legacy. It was called legacy for a couple of years, and then it has disappeared for me also, which basically meant something like this. And I'll tell you what that legacy scenario is, where the machines are not in a private cloud. What does that mean? It means something like this. This is the public internet. So everybody has an IP address here, right? So your home, your office, your laptop, in Starbucks, everybody will get a public IP address. This is the public internet. It spans this hexadecimal space ff.ff.ff.ff in IPv4. This is 256 each. And so there are about 4 billion addresses, if I am not mistaken. So IP version 4 protocol, the IP address space is limited to these many IP addresses publicly, worldwide. So when you get a machine from, say, DigitalOcean, you will get a machine directly connected to the public internet, like this. So this is your machine, and it's on the internet. IPv4 address space, you get a machine right there. Let me show you quickly. And so I will go to DigitalOcean, log in there, and just get a machine and see how quickly it comes. So I'm going to get a token, and I log in right there. So here is my login token, copy and paste. So I'm in. Now I'm going to ask for a machine. I don't have any machine. As I said, DigitalOcean, the branding is, it is going to give you a droplet. A droplet is basically a machine. So I'm going to create a droplet in the DigitalOcean, and here we go, click. It is going to ask me some questions. What do I need? It says, which operating system do you want to put on your droplet? I'll select this by default, Ubuntu 16.04. Next it says, choose a size. And since I don't want to waste money, I'll choose the smallest size. Then I'll add some storage if I like. but by default, they're already going to give me some storage. So I don't need to add another extra storage. They are adding a new feature here called block storage, extra additional SSD. I don't need that. I can choose this machine to be created either in New York or San Francisco, Amsterdam, Singapore, London, Frankfurt, Bangalore, Toronto. So I can choose whatever I want. I select San Francisco number 2. There we go. And then add my key. So here's the key I want to choose. And give it a name and say create. So in less than 50 seconds, I will have access to a new machine and I can just hook up to it. You will see that right now. And so it is going to show you that it is doing this machine creation process, and it is generating a new machine on demand. Takes literally less than a minute, and it is going to give us the IP address, which is going to be a public IP address. Like I said here, it is going to be this public IP address on the public address space, and your machine, my machine, all of us are somewhere near the public internet. And so here they got a machine IP address, copy that, and I can connect to this machine just simply by running my terminal. And you can also do that, by the way. Let me describe the concept of a security key. And so I'm going to connect to this machine just like this, and here I'm connected. There we go. And here my IP address, I can confirm that, and it is this IP address I just got. I was able to connect to the machine in a matter of minutes, literally as I talk to you. And that's how it takes to dynamically generate and start using a machine. When I don't want it anymore, I can just destroy it, and it's gone. I pay like less than a cent or maybe 2 cents, something like that. Ridiculously low amount I will spend on this transaction I just did. Now the idea here is that you get a machine directly on the public IP address, which means this is you, this is me, and this is other people, and this is bad people, these are good people, and all these people, all of them can connect, or at least attempt to connect to this public IP address that I have, which is a bad thing because that's not secure. You're exposing your machines out on the public internet. It's a bad thing to do to begin with. So that is why I say that this is not a private cloud, because it is exposing the machine directly on the public internet. Bad things happen right there. And yes, if you don't know how to protect yourself, bad things will happen. This is like, going out naked. You will catch diseases. You don't want to do that unless you're protected by proper clothing and other precautions. This is bad. Don't do this unless you know how to protect yourself. That's why people don't deploy machines like this, and that's why it is extremely popular for developers, because they know how to deal with it. And so they can start these machines, run and make use of them because they can secure themselves. Most companies prefer outsourcing that concept of security to a company that can provide them a secured infrastructure known as virtual private cloud. And now let me destroy this machine and now tell you how is a VPC different. So I'm going to droplet destroy and say confirm, and the machine goes away, bye-bye, which means I will get disconnected from here automatically because the machine died. The machine will go away and it is gone, and I don't care about it anymore because I let go of it. But again, that is a cloud, but it is not private cloud. It is not a VPC. So what is a VPC? How is it secure? That's the discussion next. Add a page. Now let us draw. What does it take to make a virtual private cloud and get a machine inside that VPC? So a VPC is basically a boundary. It's a logical boundary, and nobody from outside can get in. Nobody, including you. No entry. And you generate a machine right here. And so since you cannot get to it from the outside, what's the point of using the machine, you will ask, right? So you have to logically place yourself inside this VPC. So you may be logically outside, but you have to logically place yourself here somehow. And then you can access this machine just like a Boeing employee can access their own internal resource. And so this is physically you outside, and this is logical you inside the VPC. And as long as you are in there logically, you can connect and use and do whatever you like. That is what a VPC is. it gives you a separate internet subnet. It's a private RFC, RFC 1918, if I'm remembering number right, but it's the address space corresponding to these commonly known home addresses, 192.168.x.x, or otherwise 172 dot or 10 dot addresses that you probably know of. This address space is also known as private internet address space, which is defined by this RFC, private internet address. The RFC is, where is that? Yeah, here. So the RFC number, not access, but address. So private internet address space, not access, but address. Yeah, here. So this block of addresses, these range of addresses that you see in the search result for a private network, these addresses 10.000 all the way through these 16 million addresses, these 1 million addresses, and these 64,000 addresses are considered private, not routable from a public internet. You cannot go there from outside. You cannot go there. This is just like your home situation with your home router. When you're inside the home, you have machines. You cannot get to the machines in your home while at Starbucks outside. You cannot get to your home laptop. If you're outside in the Starbucks, you cannot connect. There is no way unless you VPN into your home. That's a rare case, but it is possible that you can logically place yourself back in the home while you are away drinking coffee at Starbucks. You can do that. So that's the kind of scenario we are talking about in a virtual private cloud. Virtual private cloud is more like your office or like your home, secure from other people outside. But you are logically there or physically there, one of these two. In case of a real private cloud where you have a building in your company, you can walk into the building. But in a virtual private cloud, you cannot walk into the Amazon building. They will not let you in at all. Absolutely not. Nobody goes in there. I mean, except very few selected people who know what they're doing. Only those people will be allowed in that area, but they don't even know which customer is deployed into which boxes, and they have no idea. It's obscured. So a VPC basically is like a private area, except you cannot physically go there. You logically go there. And what does logically going mean? It means you have to have some method of hopping through and through this firewall boundary. This actually is a firewall boundary. Let's think of it as a firewall. This is the logical boundary around your VPC that Amazon will create for you. Microsoft will create for you. Microsoft will use a different name for it. I think Microsoft uses the name virtual network as opposed to the name VPC. So the same concept, Microsoft will use the name virtual network for it. The idea is exactly the same. Virtual network, virtual private cloud, same thing, same idea, no difference. So that's the concept. Now let us do some hands-on to get us a clarity on what does this mean. So in another tab up page, you saw me do this one thing. You probably saw and you remember. I just did it a few minutes ago. I went to this site called DigitalOcean. And there I created a new machine out of the blue. Took me like 50 seconds. And then on this laptop that I have, no, I cannot write properly. Okay, from this laptop that I have, I was able to connect. And that was possible because this is public IP address. However, you saw me doing something that may sound strange to you. And that strangeness is I never typed in a password. You notice that, right? Do you know what was going on? I connected from my laptop to this public IP box without even typing a password. What happened? Do you know?
A trust has been established between that and your computer.
Trust. So what constitutes a trust?
A private key.
Yeah, so a private public key pair constitutes a trust relationship, right? So I have done it already, but some of you may not be aware of this idea of a private public key pair. So that is what I would like to talk about next. So that we will create a trust relationship and then use that relationship to actually make connections, because without a connection, we cannot connect to the cloud. We can do nothing without a connection. So this is like the first thing you need to know and understand, that you need to have a method of establishing trust with somebody, some machine out there. And that can be established through a combination of keys. It is called key pair. And a key pair is similar to your lock and key in your home or office. So in office, you have a lock and you carry a key in your pocket. And so this key can be used to open this lock and the gate opens up. That's the idea. So there's a key and a lock in real life. Very, very similar is this idea of a key pair. Very similar, although it is somewhat different, and you will see what the differences are. You will generate a pair, meaning there are two things. There is, somewhat confusingly, both of them are called keys. So there is a private key and a public key. Both of them are called keys, which is what they are actually. So that's why they are called keys, but it might confuse you with this analogy that I just gave. So don't let that analogy confuse you. However, the concept or the operation is conceptually very similar. You have to have this thing, this private key, you have to have possession of that. And then you put this public key on the remote computer, on that machine in DigitalOcean, in Azure, in Amazon, in God knows where. So you put this thing on that remote machine and you have this in your laptop. And if you have it there on your laptop, you are good. You're in good shape. You can just use this method of connection and connect. Now, this might sound very complex, but it is actually not. It is just one line of command that will create these public-private key pair and put it in your laptop. So this is our laptop, by the way. This is the machine that I want to use for the entire program. And in that machine, you will see that there is a specific location which is used to store keys. And that location happens to be this.
The .ssh?
Yes. And so that location, which doesn't exist right now because it's a brand spanking new machine for all of us, including me. This is a new VM I just imported. So this folder doesn't exist. You can see no such file or directory, right? So it doesn't exist. That is the folder in your home. So this tilde character is the indication of your home location. So your home location is actually defined by this highlight. So that is your home, and the .ssh folder does not currently exist. Okay, good to know. So what I want to now do is run one command to generate a combination, key pair, private and public, both of them, one shot, very simple. SSH keygen, that's the command, one line, SSH dash keygen, and I will type it in Slack chat and also in our notebook. So you will have a key generation. Let's go do that quickly. Very simple. Key generation is as simple as this command, SSH keygen, and all lowercase, please. Yeah, your case is extremely important in Unix. Extremely important. I cannot understate. So what that means is that lowercase is different from uppercase. Like, it's completely different thing. It doesn't mean lowercase and capital is the same thing. No, not at all. Absolutely not. So don't make that typing mistake of using uppercase or lowercase. They are two different characters, even though it might look same to you in English. So this is the command that you type, and just enter all the answers that you will provide for the first run will generate a key pair and place it in this location. Automatically will go to that location, as you will see as I starting to press enter. And by the way, you can do it along with me at the same time as we are doing it. It's very simple. And in fact, my goal is to actually use this key pair to connect to a remote machine. So we get familiarity with this idea, and we will first do with a DigitalOcean scenario. So it's a very simple scenario. Just start a machine, get a public IP address, boom, connect. That's the first step we will do. And in the subsequent to that, what we will do is connect to a VPC machine inside a VPC. So you have to like logically place yourself in there, and we will do that also. But that needs some build up, some concepts. So that is what I want to cover. But let's begin with this simple exercise of connecting to another computer away from us, Linux machine, beginning with generating a key pair. You do this exercise probably one time, or maybe another time if you happen to lose your key pair. If you lose the key pair, there is no way, like literally no way to regenerate the same private key. What does that mean? It means like this. You have a private key and a public key. This public key you can forget, you can delete, no worries. You can always regenerate another public key based on this. If you lose the private key, you're screwed. I mean, screwed as in really, really screwed. It doesn't. You cannot bring it back. You have to generate a new one. If it is deleted and lost or misplaced, it is gone. Just remember that. But public key, don't care. We can always generate these things. There is a method to do that. It is somewhere there in the website. You will find in that website somewhere here. There is a reference to that. You will look it up, and in fact, there's probably a question also on that. But as you reach that point, you will find that question and answer, and you will find it easy, not a big deal. But for right now, generating this key pair is a one-time operation. So let's do that. Hit enter. It tells you that it's going to generate a key pair and put that in that folder. And these keys have specific names, by the way. By default, they have a specific name. So this private key is called by convention, not by definition, by convention, called ID_RSA. That's the convention name. And this public key is called ID_RSA.pub. That's the conventional name for these two things. They all go and sit in that folder known as tilde, which is your home location, /.ssh. That's the customary location where people put these keys by default. They go there. If you type no other override options, these two files will get created and they will go into that folder and will sit there. That's the design. That's how it should be. You can change it, but then you need to remember what you did. This is a convention, so let's follow the convention. So in that machine where we have, let me go break this and go to our virtual machine, which is where we are working on, this one. And so in that machine, it is going to generate a public private key pair as you see here. And it is going to be saved in that folder. This is the tilde location. So this tilde that you saw here is represented by your home user location. Your login name on this computer is user. Your password is Cloud Genius. That's how it has been structured. So all of us, the login name is user. And therefore, the home location folder, home directory is this, home user. That's the directory that all of us are operating by default. So you need to remember where you are and operate in that direction, in that directory. Inside that directory, another directory gets created called .ssh, and that is the place where these keys will be placed. So this key is the private key, as you know. So this is generating a public private key pair, and this file will save your private key as defined. So we'll go enter. And next it says created a directory. That is good. So this .ssh directory was created, and it is asking you, do you want to further secure your key with a passphrase? I will say no for now. So no, nothing, just leave it empty. I don't want to put further burden on us for right now. So let us go enter. And you want to repeat that same no passphrase by another enter. So we'll enter again. And now we have a key pair created. This key pair is saved in this location, in that folder, in our home location. Our home location is the location under home user. So that's the folder we need to go to. And in that folder, you will find two files. One is this file, and another is one without the .pub. So those two files you will see. And let us go see that. Let's first go to that location. So cd tilde slash.
Can you move your screen up?
Oh, yes, I will.
Thank
I will. Yeah, here we go. So cd. Oh, that was really not visible properly. Okay, sorry about that. So .ssh, that location is where we will go and then list out ls-l to list those two files will become visible to you. Simple. And let us be careful about the private key. As you know, this is your private key and this is your public key. You can, as I said, generate the public key, but you cannot generate the private key, exactly that one again. It is once it's gone, it's gone. It's lost. You cannot revert. You will also notice one thing, that this IDRSA file permissions are limited, very, very strongly limited, just for the user to be able to read and write. Anybody in the group cannot read and write, and other people cannot read and write. The access is very limited. And this is a requirement for this private key. If the access is not limited, it will not work. It needs to be like this, RW for the user. And this file permission structure is kind of sort of new to people from Windows background, so I will elaborate a little bit on that. The file permission structure is conceptually like this. So it is defined as three places of, actually it's octal structure. So the idea is that you write in these three sets of bits RWX permissions: read, write, and execute permissions. So this is for reading, this is for writing, and this is for executing. So read, write, execute permissions. So you have to have 111, meaning people can read and write, and execute it becomes a binary file, executable file. So those permissions you are giving to these three types of people. This is you, this is your group membership that you belong to, and these are other people using the same computer. So others that have access to the computer, those people will be classified as other. These people are your group members, and this is you. So if you see permission structure like R, W, nothing, it tells you that this particular entity can read and write and not execute. It cannot execute. Another scenario, you have three dashes, meaning this group entity, anybody who belongs to the group, can do nothing. And other people, it might show you dash, dash, and dash. It means these other people can do nothing, no action. Read and write, yes, no execution. And that's how this collection of permissions is defined, at least at a very simple level. There are more complications in Windows land. If you right click on a file property, go to read, write, access permissions. In NTFS file system, we have another method of controlling access permissions. It is very similar to that, except both are different. So this is the Unix way of doing it, that is the Windows way of doing it. So in this example, in the private key, public key pair combinations, we are using the Unix style references. So that's what you're looking at in this file. It is RW dash, 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 dash. Meaning this particular private key can be read only by you and written to only by you. This public key can be read or written to you by you, but group members in your group or other people using this computer can only read the public key. That's the definition. And these permissions need to be, especially for the private key, needs to be like this. Otherwise, the key will not work. Even though you have it, it will not work.
Nilesh,
Yes.
is the permissions in Unix on the file or on the directory, or can it be on both?
Both. So you can see the directory level permissions by going one level up and see. So you can see that this folder called public. It has similar structure except that the directory is D, defined with the beginning letter D, and then followed by RWX, RWX, or R-X, R-X. So this dash means like, other people and group members and other people cannot write to the directory. They can X in the context of a directory means you can explore or open or read or view the list of files inside the directory. That's what X means in the context of a directory. And D is the indicator of a directory structure D, the initial D at the beginning. Now you will also notice something, that this .ssh folder is not visible to us in this listing. I just said ls-l, show me all the folders or files. It did not show us that .ssh. Why? Because of another convention in Unix, which is the dot indicates hidden things. So .ssh means it is a hidden folder. I can see it on the directory listing, but then I have to specifically call it out saying, show me all of them, LA, show me all of them, and then I can see them. And so here you see lots of them with dots, Ansible, Atom, this and that, and somewhere along the way you will find .ssh. This got created September 16th at 0057 UTC. So this is the Universal Time Coordinated London time, which is right now, just about right now, 1 a.m. And so, by the way, Unix operates in UTC time zone. So you can all, of course, show your clock in whatever time zone you want, but the underlying system clock is tied to UTC. And that's what you saw, this SSH folder. If you go in there, inside that folder, like cd.ssh, you will find that listing, and you will find those two files, private and public key. Now let us open these two files to see what they contain. So we can use this editor built into our machine, which is called Atom. It's another open source project from GitHub, which is actually very nice. By the way, there is another new editor that just come out. Microsoft has released an open source editor called Visual Studio Code that runs on Linux. And maybe you should install that if you like. But we have this installed, by the way, called Atom. And so Atom followed by a period or dot will open up the editor and will show you content of these two files. And by the way, technically, I'm not supposed to show private key to anybody whatsoever. And that is why you should remember to not share your private key at all with anybody ever. This is like sharing your password. Bad things happen. So, but I don't care, I'm going to share it. Here we go. So it is going to open the editor and show you two files, and the editor opens up, and you see on the left side, there are these two files showing up right there. This is the public key. You can examine. It's a one long string of never-ending characters. But let me toggle the soft wrap, and you can see that the file actually is, okay, hold on, view. There. So this is actually a bunch of characters, one after the other, written down in a very structured, systematic fashion. Let me go and explore and expand the size of it. You see from a distance, I want to point out a couple of things. The indicator of SSH RSA is the beginning item. It is a part of the key. It has a space character after that, followed by a long list of characters after characters after characters, all the way up to this point. And so after this highlight, there is some more characters which indicates a comment indicating the user, which is you or me or things like that. It's a comment. Now where the key begins and key ends, let me identify that very clearly. The key begins all the way at the very top, includes SSH-RSA space, followed by the string. And the remainder that you see at the bottom, user at Cloud Genius, is just a comment. It is not really technically a need. It can associate itself with the key, but is not required. It is not a part of the key itself. It's a comment appended to the key. So this is the public key. It is okay to share this key with anybody and everybody. However, let's go to the private key, which is the other file here on the other side, up on top. click, and you will find this file is also another very long series of characters generated through the RSA algorithm. RSA, as you know, are three scientists known as, I forget their names, but those guys are Ronald Rivest, Leonard Edelman, and Adi Shamir. These three gentlemen who are, I think, now a part of EMC. They started this cryptography algorithm called RSA, and these keys by default are generated as an RSA key pair. And that is the RSA crypto system that we are talking about. I'm going to paste that link in the notebook so you have it there. And the link goes in that location for some reason. I will adjust it later. So we move it here. So that's the RSA cryptography description reference. And the key pair is available to us. This is the private key, as you see. Now, you will never share this key with anybody, and I have shared it. I don't care. But you don't. Please don't. Now I'll close this window. You can close this Atom window by pressing Control W. Control W will close a window, and Control Q, I think, will quit this application. Atom will quit. Control Q. So I came out of Atom. We have created a private public key pair. Now how do we use it? Let's go use this key pair. So usage in practice. So first thing first, we need to get to that site, which is where this coupon is available for you to get some free usage. So you should use that and start up an account with DigitalOcean, and then create a machine over there and connect to it. Just make sure that you are able to operate like this. So on this site, on Cloud Genius site, on the left-hand side, you will find free accounts with cloud services, and that is where the simplest cloud imaginable is available. This is very simple to use. It's DigitalOcean. They're giving you $10 worth of usage. Take it. It will run you one machine for 2 months. $10, $5 a machine. That's the pricing. And this link will give you that built-in referral coupon, which will give you $10 worth of usage. And that's what you should click through so you get some benefit. I mean, yeah, why spend? You're not even 10. So use that, go through there, and then sign on to DigitalOcean. And I am already there, logged in. And no, not logged in. So I'll log in again. And now I'm logged in. So this is where I am connected. They will ask you for a credit card. However, just remember that this is going to give you a $10 usage credit, which means that you can create a droplet and use it for 2 full months without having to pay. By that time, the course will be over. So don't have to worry about it. And this $5 droplet is decent, powerful enough, and fast enough for us to experiment. This is not a secure VPC. It is not a secure virtual network. It is not protected by a well-designed firewall to begin with. Just realize that. And after having realized that, go ahead and open an account. And yes, you need to give them a credit card, and they will give you $10 coupon through the link that you saw. And let us use that. And remember one thing. Whenever you're done with using a droplet or a machine or a cloud instance or whatever, we will do tons and tons of these things. Remember that after you're done playing with something or experimenting with something or doing something, remember to destroy. I have seen people accumulating bills, a huge amount of bills. That there is a reason for that. But I don't want to waste money. I don't want you to waste money either. And so do not leave the machines running. You will forget them and leave it running, and you will accumulate charges on your credit card, and this $10 will finish off. It will eaten away after 2 months. You will realize that I left a machine running, and now DigitalOcean says that you need to give them $10. Don't do that. Kill the machine after you're done. That's it. That's the whole purpose of cloud, is to get a resource when you want and then get rid of it when you don't want it anymore. So remember that definition itself, and relinquish a resource that you get whenever you're done experimenting, playing, toying around, whatever you're doing, messing around. Just kill it, destroy it. That's the best thing you can do, at least from a usage perspective. It's your own money, right? Don't want to waste it. So open an account and hop online here, and you need to somehow send this public key to that company. the company that is going to give you a machine, because this public key needs to be sitting in that machine over there in the remote computer. Only then you can connect to it. And let's walk through that understanding as to what does it need to happen, what needs to happen for us to somehow give our public key to this DigitalOcean company or to Amazon company or to Azure company or God knows who. But they need to put that public key in the machine or in all the machines you will create. And then you can connect, no problem. As long as you have a public IP address, you can connect. If you don't have a public IP address, we'll deal with that situation next. That's the next logical step. But until that time, let's get a public IP address machine. Make sure that our public key, which is this one, is somehow magically, and not magically, systematically provided to the company that is going to give us resources. They need to know which public key you will want to use, and so you need to give it to them. As simple as that. As simple as that. And so as soon as you have an account, let us find out how can we give this public key to them. And so the best way to give it to them is to just copy and paste. As simple as that. So I will begin to paste it in my screen. I'll just type it out. Type command is called cat, C-A-T in Unix. So I'm going to cat this command, cat this file, cat idrsa.pub to type it. And I can see it here. This is the content of my public key. What I intend to do with this is I'm going to copy this like from here all the way up to this point and copy. And by the way, Control-C will not work because this is Unix. So you have to right click and copy. That's the only way. There's other ways. I'll get to that. You can actually use keyboard combinations also, like Control-Shift-C, for example, to copy. Otherwise, you can just right click and copy. That also works. But remember, as you copy, you need to be careful as to what you are copying. You need to copy the public key. So you have to concatenate, type it out on the terminal, cat, that file. You need to be in the folder .ssh, which is this folder .ssh. And then you need to cat the contents of the public key, not the private. You're not giving anybody the private key at all, ever, never. Because that's what happens when you lose your private key. I have seen people in the program lose $2,000 for stupidity because they post the public key, so the private key on GitHub. And I've cautioned people against doing that, but people just do it. I don't know why. And then there is a way around. Now you have to call Amazon, explain to them, sorry, we made a mistake, and Amazon will just revert. And people are exploiting these keys sitting on GitHub. By mistake, people just push it to GitHub. And it is actually idiotic to do that. So don't do that mistake. I'm just cautioning everybody again. Never, ever, ever give out your private key to anybody. And that's a caution. Having said that again, I'll do it one more time later, sometime. Not right now. So public key you can cat. And then once you cat, you can copy it in your buffer like this. And then right click, copy, keep it in your buffer. And then go to DigitalOcean and give it to them. That's it. That's pretty much it. So we will assume that you now have an account. By now, I think you should have created an account. If not, I'll just wait a couple minutes more. But you should be at this moment verified, have your credit card, and ready to see first thing first. Do I have my $10 applied? So you should check that. You should check in the billing section. They should show you some credit there. So yeah, you should see that there is a credit applied or something like that. So I don't see it because I don't have a credit, but you should be able to get that credit showing up in your billing tab. The $10 credit should show up. And if it doesn't, tell me, because after it does, we should be able to start a droplet without wasting money. And then we will create a droplet using some operating system. So the default is good. don't have to spend too much money on a big machine because we don't need it for right now. We'll just use the $5 machine. That's good. We don't need to have an extra block storage. No need to add. They already give us some block storage. Some storage is already made available to us, and that storage is 20 GB. It's good enough. We don't need additional storage, not needed. So no additional block storage needed. Now we need to select where do you want the machine to be created. Do you want it in New York, San Francisco, or Bangalore? I don't know what. You pick your location. And how do you pick a location? You pick the location based on where your customer is going to be. Not where you are, but where customer is going to be. So if my customers are going to be in Singapore, I will choose Singapore. If they are going to be in Bangladesh, I will choose India. It's geographical proximity. Unless I can prove that Bangladesh has a dedicated internet access connecting straight to Singapore and not to Bangalore, I will then choose Singapore, because the proximity connectivity between Bangladesh and Singapore is better. I will go with Singapore. The idea is to provide lowest latency to my customer. So if my customers are in Bangladesh, I should select and actually study. And I'll create two machines, one in Singapore and one in Bangalore, and ping from Bangladesh and understand which machine is performing better for my customer. And then choose that location to establish my machines, my infrastructure. I will create my infrastructure closer to my customer, not closer to me. That doesn't make sense. Close to the customer. And that's what you should select when you're selecting. So having understood that part, I'm just going to select close to me right now because that's what I care for, at least for right now. This is a machine just for me, so I'm the customer. And so I will select San Francisco. That's the closest apparently. And so here we go, San Francisco number 1 this time. And these number 1s and 2s and 3s, think of them as independent data centers in the city of San Francisco. In Amsterdam, there's data center number 2 and data center number 3. Can anybody guess what happened to data center number 1? Anybody? Any guesses?
Already used up.
Yes, it's full. There's no room. So they cannot give you there, right? So it's occupied. So it's one of the oldest ones that they had. And so it is so much occupied. It's like full capacity. So they cannot allocate the new space there. And so it is full. So that's the limitation, right? But yeah, that's Amsterdam number 2 and 3 are available. 1 is not. Bangalore just opened a couple of months ago and things like that. So yeah, that's nice that they have it in Bangalore. I did not expect them to open, but they did. Nice. That means India is growing. Okay. So selecting San Francisco 1 because I'm the customer for this machine. And now let us skip the additional options for now. We will go to them later on, but let's understand.
Hey, Eli, quick question.
Yes, please.
What SKU did you choose?
Sorry?
What SKU did you choose? The 5-month SKU, the 10-month SKU?
$5. No, it's not 5 months. It's $5 per month.
Oh, yeah. Okay.
Cheapo. Cheapo is good.
Okay.
I don't waste money. It's an exercise.
Awesome.
Don't waste money. Cheapo is good.
Okay.
Yeah, we'll use the $5 machine by design everywhere along, except in one exercise where we need to have a big machine because it requires more memory. And I'll tell you at that time, until that time, $5 machine is a good one. Yep, just blindly go $5. No need to think about.
I'll take it.
Cheap is good. Don't waste. So yeah, Ubuntu, $5, any data center you like. And let's skip the additional options right now. And this next thing is where you provide your public key. And I have some public keys already there. And so I'm going to delete a couple of them just to bring some clarity. So I'm going to go delete them while I can demonstrate to you how do I add my own public key to this cloud. And so here in security section, you can see that I have these tons of older keys that I want to get rid of. So here we go, bye-bye. And bye-bye to this one. Yeah, so I'm going to keep these 2 keys. That's great. And you can actually, if you're not in the mood of creating a machine right now, you can just add a key right there. and paste it. That's it. That's all it takes to create a key. And you can give it a name, ID_RSA if you like, and add the key. That's all it takes to give them a key. There it is. And now I have my public key given to the DO cloud. So the DO cloud now has my public key right there.
Can we take a quick break?
Yes, please.
Thank you.
Yes, please. So we'll take a break. We will resume our discussions in 7 minutes from now at 6:30 p.m. So right now it is 6:23. We'll resume discussions at 6:30 p.m. and I will still be here. I'm not going away.
So Nilesh, quickly, I missed a couple of steps. So I have selected a San Francisco.
No problem. Yeah, go ahead.
Scroll up a little bit. What did you select in the additional options? Did you select anything or no?
No, nothing. No, we are not selecting any additional options. In fact, I'm going to begin from beginning. And here, I'm going to select Ubuntu OS, select the cheapo droplet, no block storage, select some region like you like. I like San Francisco.
Yeah, that's
and
what
then I will select my SSH keys. And if you don't have this already, then you new key and paste. New key and paste.
So new key, and then I paste whatever is from my public.
Yeah, whatever your public key is, you grab it from here, paste it in DigitalOcean, and there we go. Right?
Okay. And then did you have to give some name to that?
Yeah, it is going to give you a name by default. You can change it if you like. My preferences are something like my computer.cloudgenie.us. Yeah, that's how I name, but it's immaterial.
Yeah, I know. That's
Name
fine.
whatever you like. So this is the name I choose. Yeah, you can choose whatever name you like. It's actually immaterial.
Yep.
It's not a domain name. It's just a host name.
Okay, and then add that. Okay.
Yeah. By the way, is there anybody who's finding this discussion too trivial? I should know. There's at least.
I'm familiar with all this private public. Yeah, I use quite a bit at my work.
Okay, that was Mukesh. Mukesh,
Yeah.
Okay.
And same here with me.
And that was
Because
Ram. Yeah, I suspected that. You're a hardcore man. So yeah, some of this will be too trivial for you, and I'm sorry for that.
no, it's fine. I mean, I have to see how it fits in the context. That's the key.
Yeah, I think the context essentially is that key pairs are a primary mode of connection.
Yeah. Okay.
And that's why we are beginning with this discussion of creating our own key pair, giving the giving the public key to the cloud providers so that they can then, when they start the machine, they can place this public key in a very specific location. And I will show you that as soon as you connect. Yeah. And there is in fact a very, very systematic method of managing this access and controls, and lots of things to discuss as we connect. So we'll do that in 4 minutes right now.
Yeah, so I work for Boeing, and they're mostly, roughly about 95% of the servers now, they have stopped allowing FTP. So everyone has to use SFTP, the secure.
Nice.
So because of that, obviously, we go through doing this, public key concept of doing it, because if you're wanting to use scripts to automatically send files or bring files and all, then you can't have an interactive.
Correct. It'll bog you down if you're not using a key.
Yep, exactly.
Yep, makes sense.
Hey, Nilesh.
Yes.
I love the Unix command line stuff, but I think I need a refresher. Is there something I can go to?
Yes, there is a good course I will tell you about, Intro to Linux. And so this course you should take. It's a free one. I'm going to paste a link for you. And the link is going to be directly to you. That was David, right?
Yes, sir.
So David, in your Slack chat, you have a link. It's a quick course on Introduction to Linux. It's a free course from edX.
And I assume it's self-paced. So
self-paced. You can just zoom through it. Yeah, just zoom through it.
With it. I'm just having flashbacks of it. It's just.
I know. I understand. And yeah. So I'm going to paste this course for everybody if you're interested, but I think it is too trivial for some of you. So just ignore that. But this for a first timer or a refresher, it's a good course. It'll take you like maybe a couple hours to zoom through it. If you used Unix before, this doesn't take long.
Awesome. Thank you.
Yeah.
My stupid DigitalOcean blocked my account. So
Aha.
due to a verification of my zip code apparently on my credit card submission. So I'm probably not going to be able to follow.
Okay. No worries. So if you need, I can, that was Mark speaking, right? Was that Mark?
Correct.
Okay. So what I will do is I'll give you my account. You can use my account. No worries. We'll deal with that. So I'll pass on my private key and my credentials. So you can use that, and we'll figure out. So you should not be behind as such. You will deal with the credit card zip code issue later, but I'll give you access to mine so you can continue. So is it time? No, we have 2 more minutes. Yeah. We don't have to wait. If all of us are ready, we don't have to wait for the time. The time is not like I arbitrarily chose 6:30. I think this OneNote for school classroom is really nice. I really like it in that it lets me write using a pen, and I can share it with all of you. That makes it beautiful. Beautiful. And of course, video recording. Is it recording? Yes, it is recording. That's good. I was just checking that.
Another quick question.
Yes, sir.
With DigitalOcean, if I pay the credit card thing, and I, as you say, destroy all of my virtual machines, I'll never get a bill besides whatever time I've used, or do they default bill you $5 a month?
No, they do not default. It is pay as you go.
You have to use the service.
Yeah, if you use it, it's actually the pricing is not a monthly pricing. If you go look at the pricing that they provide, where is the pricing tab? Here. So let's scroll through the pricing, read it carefully, and it is actually an hourly minimum. So hourly usage. So it's going to be 0.7 cents. Yeah, less than a cent per hour. That's the bill. If you use for 1 hour, you will be charged an amount of $0.007. If you use it for more than 1 hour, you will be paying 1.4 cents. That's it. And it will be deducted out of your $10 whopping $10 coupon that you might have by now.
Mm-hmm.
It's quite a bit of money. $10 as such is, yeah, it's okay. Don't worry about it. So the idea that I think we should be able to proceed forward is that we have managed to give our public key to this company. And the unique thing about this cloud, and like Amazon, no, not Amazon. Amazon is kind of different. I'll tell you how is Amazon different. But every other nice cloud will operate just like this, that you give the key to them one time, and then that's it. They will use that key across New York, San Francisco, Amsterdam, this and that, and Bangalore, everywhere. You can use the same key. It doesn't make you create and provide a public key to Singapore, different from Bangalore, different from Frankfurt. And you will see this problem in Amazon, where you have to, unfortunately, in every region in Amazon, the key pair has to be provided to them one at a time. And that is boring. I mean, boring to say the least. And this is a legacy of being, front runner 7 years now. I think since 2008, Amazon has been operating, and you live with the legacy. I think that's the problem.
So you have to provide that key on every location, or they will not propagate for you?
No, they don't propagate. No. Yeah. That's the fact that you need to be remembering that in Amazon, you have to provide the public key to every region.
No.
It's lame, but that's how it is.
You have to do this to this ugly UI?
Yeah, you can do through UI, you can do through API. There are several methods, but then there is no method of propagating. Once you give it to Virginia, it doesn't automatically go to Oregon.
Oh my God.
Yeah, just realize that it doesn't. But whatever.
I was successful. I have a droplet created.
Sweet. So when you create a droplet, did you manage to provide a key to them?
Yes, I pasted in my public SSH key and called it my public key.
Good. So when you add your public key, like I have added this public key, and I'm going to select it right now. I did select. So this public key is now selected, and I'll just quickly zoom through. Ubuntu, $5 droplet, no block storage, San Francisco, no additional options, add my public key, IDRSA, and then choose a name. I'm going to choose this name, whatever, literally whatever. And then that whatever machine should start as soon as I click the create button. So I did. And the machine will start in less than a minute. That's the promise from DigitalOcean, that they will provision your machine in 55 seconds or less. And so that's generally true. By the way, it actually works out pretty much like that. So most of the cases, you will have a new machine ready within 55 seconds. And here is our machine booting up, getting loaded with the OS. And we will get an IP address like that. So we have an IP address.
Now, once created, is there a way to double check that my SSH key went in?
Oh yeah, we will check that right now. And that's the simplest way to check, is to just first thing first, copy the IP address, right? And go to the terminal right here. In the terminal, you want to remember to not work in this folder. That's not a good place to work. So you want to come out of it by saying CD and tilde. Tilde means go home. So we want to go home. And now we are home. This is the location you want to work on, CD tilde. And at least you know where you're working on. You work in .ssh folder, you will create trouble. And you will hit, I want you to enjoy. I want you to really understand and enjoy doing things as opposed to getting frustrated. So remember to work in the folder that you're working on and be aware of it where you are. Best way to find out where you are right now is to type pwd, enter. It will tell you where you are. Present working directory is this location. You want to go home, you can say CD tilde, go home. And be at home. That will be a nice place to be. Home is nice. And so that's where we are right now. And now we will actually attempt to connect to this IP address that we now have. The connection string has to be established very, very simply. It goes like this. SSH. Rather, I should make some space to improve readability. So SSH followed by, we have to now provide our private key to the command. Like this. We are telling our command, make use of this private secret key that I have and use this to make a connection to this machine with this login name and this IP address. So the connection string is very simple. It is the IP address goes right there that I got from DigitalOcean. My login name on the remote machine in DigitalOcean by their documentation is always root. That's the name. Always. In DigitalOcean, that's the name. In Azure, you can choose the login name you like. In Amazon, the login name is Ubuntu if it is Ubuntu OS. EC2-user if it is any other Linux user, and administrator if it is Windows. So they have conventions established over the years, and that's every cloud provider will have their own chosen username. In DO, the username is root, the IP address you just obtained, and the connection string SSH-I. This means use my private key, this one. That's the private key I want you to use, and use this to make a connection, this private key to connect to this machine at this IP address using the login name root. And that's the way to connect. Now, as you begin to connect, you will watch a couple of things happen right now. And I want to make sure that you get this particular command very simply. It is SSH-I. I'm going to just copy this and put it in the notebook. So I'm going copying it and putting in that notebook right there, maybe here. Yeah, this is a good one to connect. So there we go. This is a good one. So that's how you connect, and your IP address goes in that location like I mentioned here. You should change this IP address of your droplet, of your machine, of your whatever instance. Different people, different companies call things, same things differently. Amazon will call it an instance. Azure will call it a machine. And DigitalOcean will call it a droplet. So it's, yeah, whatever. It's a machine. So IP address, as you see, root at symbol, and you get the IP address from the service provider.
It's telling me it can't verify the blah, blah. That's okay.
Yeah, that's a good sign. That's a good sign. So I'm going to enter, and I'll explain to you what is going on. So it says, you know what? It says authenticity of this machine IP address. I don't know what you're trying to do, sir. That's what it's telling me. This is telling me, I don't recognize this animal. Do you recognize what you're doing? Are you sure you want to connect to this machine? That's the question. And the answer is yes, because we absolutely know that that's the machine we want to connect because we just created it, right? So I'm going to say yes. And before I say yes, I want to point out to you another thing. So in a separate window, I'm going to show you another thing before I say yes to it. And that thing is this other file, which doesn't exist yet. And that is going to be getting created in that window. As you will see, as soon as I say yes, a new file will get created in this location alongside these two files. And that is called a file of known hosts. Known hosts. So basically, right now, this machine, 159 dot whatever, this machine is unknown to the command. It doesn't know whether it should be trusted or not, whether you should attempt a connection or not. So it is scaring you. Are you sure what you're doing? Do you know this host? And yeah, I will say, yes, I know. I want to connect and continue. So as soon as I say yes, which I will, by the way, I will say yes. So I'll say yes here, and I will see that it connected successfully, and I'm now connected to that whatever machine right there. This whatever I am connected to. Now on the other screen, which is also open on the side here, I will see that I have a new file opened up. And this is a collection of all the machines that I know and trust. Known hosts. I know these machines. I know them. They're good. I connect to them. I have a trusted relationship established, and I know them. So it keeps track of what is in that file. Is basically a reference with a hash to the machine I just connected, like this. So this hash represents the machine that I'm connecting, and it keeps track of which machines I know and trust. And so that's what this question was. Are you sure what you're doing? Are you really, do you really mean to connect to this machine? That's the question. And we said yes, and we got connected like that. Great. I want to come out of the connection by typing exit, E-X-I-T, enter. And it comes out. The connection is now closed. I will attempt the connection one more time by pressing the up arrow. So just go up arrow. It'll bring the previous command for you. So you don't have to type the whole thing again. Just go up arrow. And that's how it brings up. And this time I will attempt the same connection one more time. And you will see this time the host is known. So that warning will not be there because it keeps track of which host that you know. It's a known host. It's not an unknown host. So it will just shut up and connect like this automatically.
And it's using your now private key against the public key we stuck in that image.
Yes,
in
yes,
order to validate, verify, and connect you.
Correct.
Somebody else tried to connect now to our machine, it would reject them if they did.
Exactly. It will. In fact, I can show you. It will reject. So, for example, I just exited, and I'm going to ask one of you to please give me your IP address, and I will see how it fails on me. So I cannot connect to your machine, and you cannot connect to my machine either, right?
Yep.
I cannot do that. So give me an IP address that you have running there.
104.
236.
Okay, there you go.
163. 157.
Right. So this IP address, I don't have the private key, and it will fail on me. First of all, it will say, "Do you know this?" And I will say, I will lie. Yeah, I know. This is my machine. I know it. I'm going to lie this, right? So that's the only way I can go forward. If I don't lie, it will just come out right now. But I'll say, yeah, I know. This is my machine. Attempt. So I'll say yes. And it says, yeah, give me the password. I added it to a known host, but the key failed. Give me the password now. And that is a sign that it's not going to work because I don't know the password now. So there is no password, by the way, even you don't know. So break it by Control C to break it. So I came out, but I lied. So my known host file is now containing 2 entries, which is wrong. I need to have only 1 entry, which is the right one. So I need to delete that entry because I lied. And I basically falsely said, yes, I know. And that's not how you're supposed to behave in sane life. And so I'm going to get rid of that other known host entry just to be clear about things. So I'm deleting that.
That the public IP actually provided you the public key.
Yeah, the public key, it will be, yeah, it does. But private key you need to have, and you cannot generate a private key just because you have the public key.
No, yeah, I get that. But just by giving you the IP address, the machine actually gave you the public key.
Yeah, machine does. Yeah, machine gives you, so you can validate the connection and establish that. Is true. That is true. Now let's go back to my machine itself. So I'm going to connect to my own machine. So if I go up arrow more times, like up, 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 it will take me. Let me open the terminal again and make it size bigger and go up arrow a couple of times to get to that IP address, which is mine, which is this one. And then I enter. So I connect and I get successfully connected. Now I will show you a different idea right now here, which is another new sheet of paper. And in this idea, I just mentioned, and we discussed this file called known hosts, which is basically a collection of all the hosts that I know and I want to connect and all that good stuff. And this file is on your laptop. Correspondingly, on the other machine out there, the servers or the machines or instances or droplets or God knows what, there is another similar concept, which is analogous to this concept, symmetrical to this concept, not exactly the same, but symmetrical. The concept is authorized underscore keys. So very, very symmetrical. Just like on my laptop, I have a list of all the machines that I know and I connect. On the server side, it keeps track of all the keys it can accept connections from. That's it. So it's very, very symmetrical idea.
And if you go check on your droplet, you can actually see the activity of hitting that machine. Yeah, it's pretty cool.
Yeah,
awesome.
So you should be able to see that right now on my remote whatever machine. I will go and examine the same location, cd.ssh. And in there, I will list, and you will find the authorized keys listing. And this is a exhaustive list of all the public keys which are authorized to connect to this box, right? So let's go cat authorized keys. And what do you see here? You see my public key. This is my public key. I'll go and make sure that I can compare this with you and show you my public key on a separate window right here. So here is my public key, and you can compare item by item and it will match. Let me make the font size similar, and there we go. You can match it. Line by line, item by item, you can see that the file is exactly the same. See, it ends with B2BZ. It also ends with B2BZ. It starts with AAAAB, A3NZA. It also starts with this. Same thing. It's the same public key that DigitalOcean took and put that in this authorized keys file, this file. And it dropped in the image and then booted it up. And so this idea of, there's only one key, by the way. So it's not keys, but it can contain multiple keys. In fact, I would like you to give me your public key, and I will incorporate that manually in this file. So paste your public key in Slack chat, and I will add it to this list of authorized keys. And then suddenly you can connect to my machine because I am authorizing your public key by adding it to this file. I will add that. You paste it in Slack chat. I will take it from there and put it in this file and let you know so you can connect. So right now, this authorized keys file contains only me, only my pub. And I want to add your pubs also. So
Sorry,
that,
can you give the command to get into the SSH directory again?
yes. So it is cd.ssh. Or rather, I should be very, very specific, and it's called cd home/.ssh ~/.ssh. Then you can cat your private key. And then you copy this private key, paste it in Slack chat. I will incorporate into the authorized keys file. And then magically you can access my machine.
Unless you meant public key, not private.
Oh yes, sorry, oops, sorry, public. Never ever give your private key to anybody, including me. Never, only public. So yes, thank you for correcting. Give me your public key, please. And I will add that here in this file. And I'm looking for Slack chat now. Anybody? Yeah, you can comfortably share your public key with the world. No worries there. Private key, no, don't share. There we have. Mark has given his public key to me. I'm going to copy that whole thing. And you see how I'm copying. I'm including the SSH, copying that, making sure that it is sane as in no copying mistakes. So I am going to open Atom Editor and make sure that the key structure is intact as I copy from Mac and bring it to Linux. And so I'm going to paste it here. And I think I did a good job in copying, I hope. Come on. I think I did, yeah. So the copying succeeded. That's awesome. So I'm going to close this window out. So don't save. And instead, I'm going to go to this ID authorized keys file and edit that. And at the bottom of this file, I will paste the key provided to me by Mr. Mark Myers. And now Mark is authorized to access my machine, and so am I. Now let me give Mark my IP address so that Mark can connect. So my IP address is right there. I'm going to copy it, give it to Slack chat, and my IP address is going to be available to everybody. So here we go. That's the IP address. Please come on and party. So I'm going to now take Mukesh public IP address from Mukesh, copy it over to the machine out here and edit. And as you can confirm this, authorized keys I'm adding at the bottom. Oops, I'm going to add it at the bottom. It doesn't matter, order doesn't matter. So opening up space at the bottom, pasting key provided to me from Mr. Shahi, and Mr. Shahi is now successfully authorized. As you can see in this listing of authorized keys, you have now 3 keys. The first key is mine, second is Mark Myers, third one is Mukesh. And now Ram has given his public key. I'm going to copy that over and authorize it into my authorized keys list.
Nilesh, what's your IP address?
I pasted in Slack chat, so you have it.
Okay.
And so now you should just use my IP address and come on in. Let us party. So the idea would be that I just added not only me, but bunch of other public keys. So here, Nilesh here, we have Mark here.
I'm now connected to your machine, just FYI. It
Awesome.
worked.
Yeah,
Yep.
worked. Yeah, nice.
Awesome.
So, and Nilesh, Mark, and Mukesh, and Ram. And so all of these guys can now authoritatively connect to this box because they are authorized. And this is the process of authorization of a key, right? Basically, you put that list of keys like this one. This is 1, this is 2, this is 3. 3 keys that you show here. And I have another one also, but that doesn't show because I did not cat it. So 4 keys showing up, and there are probably more. Let's see if more people have given me keys yet. But yeah, you get the idea. The idea is simple, very, very simple. It's very symmetrical to think about it like that. So the idea is, on one hand, you will have multiple people, like multiple people with multiple laptops, worldwide, and multiple machines worldwide, servers, right? And you need to establish this many-to-many connection. So this many-to-many linkage happens by the fact that you have many people, so M people with laptops and N machines. I should use different words. So it's called P people and M machines, right? So there's these many machines out there. So you have to have M entries in the known host file. This known host file will contain entries corresponding to these M machines. They are known hosts. And similarly, the authorized keys file, this file will contain P entries, because P number of people can connect to this M machines. So that's the map. That's the P to M mapping. So people, machines, connect. Known host, authorized keys. Simple idea. And generation is also very simple. Everybody needs to generate their own key pair, which is simply SSH-key gen. One line. It generates the whole thing. And you use it like we described here. Known host, authorized keys, and connect. That's it. That's it. Any questions on this?
I see like there are 4 people on your machine right now.
Okay, let's see who. So yeah, there are 4 people showing up right there. So I can see them. These are IP addresses. This is my IP address. This is somebody else, somebody else. I don't know who's who, but yeah, you get the point.
Different IP addresses.
I'm hiding it. Hold on. I'm hiding from you. Okay, I'm on the window apparently. Okay, let me go away. So yeah, I disappear. No. Yes, I did. So here you can see these IP addresses at the bottom right corner. I was occupying that territory. This is what happens occasionally when you want to show your face and then the terminal is behind you. So, but you get the point, right? You get the drift. So any questions on this aspect of, fundamentals of connecting, establishing trust, and, connecting A to B, P to M, people to machines? Any questions on this aspect?
No.
Nope. Good. So next, this idea can be extended now. So the same idea that we just discussed, we discussed this in the context of people connecting to machines, right? So we had P people, M machines, and we just do this mishmash connection, right? We did that. Now in automation, you can actually create fictitious people. When I say fictitious people, I mean it is in common parlance known as service accounts. You can create service accounts that are assigned to machines running your automation tools. So you don't need to have a person all the time, but instead just let him go on vacation. Instead, have your machines that are going to run your accounts, service accounts, connect to your servers in the cloud that will get managed through your service account, that you want to do some critical operation, some surgical activity, whatever you want to do, like what people do, that machines do that part. And so the same idea you can extend, as long as you make sure that these service accounts that will have a corresponding private key public key pair, that you will never expose the private key, and you never send the private key itself out here. Don't send it. No. Private doesn't go. Private stays with you on your laptop, on your corporate workstation, on your desk, in your home, somewhere else safe, but don't send it anywhere ever. Okay, so the idea is to replace people and put machines in place as service accounts. Cool. Now, next step, which is to understand how do we now connect to a scenario which is not really in a public IP address. Like we don't have a public IP address. So what do we need to do to connect? So now up till now, what we have done is that we had a public IP address to begin with. But that may not be the case, because if you are in a virtual private cloud, they are not going to give you a public IP unless you ask for it. By default, it is not going to give you a public IP. So how do you connect? And what design or what architecture do you want to draw around it to make sure that we actually succeed in connecting? And that's what I will now illustrate, that concept, and then build on the idea to connect to a machine. But before we get to that point of connecting to a machine that does not have a private IP, does not have a public IP address, you need some way of hopping on to the internal area. Like by a hop, I mean, think of it as like an island. So this is the island. And you have alligators here. All around, alligators. They're all around the island. And you want to go to the island. So the machine is right here. And you are outside. So you have to establish it. And by the way, there is no boat available. And you don't know how to swim, and you don't have any weapon to deal with the alligator. So you're basically, you just have a laptop and internet connection. But you don't have a way to get to the island because you are on the mainland. And this is the mainland. So you want to get to the island. There are a couple of ways. Interesting ways can be to dig a tunnel and go. So this tunneling is the operation that I want to discuss. That's why I'm just drawing this illustration. And so we will do some tunneling over SSH to connect and then hop onto a machine on the border here that will let us then hop onto this machine, and then we connect. So it's a hop that we need to have somewhere along the way. That hop is provided by a tunnel machine, also sometimes known as a bastion machine, or sometimes known as a jump box machine. So you can call it by whatever name you like, but the purpose is to be able to jump from mainland to the island, and then from there hop on to the right location which you want to go to, which may not have a public IP. So no public IP for this guy. no public IP, but you can still connect to it comfortably. And I will show you how by doing it. But before that, let us understand this concept a little bit. So the concept now. The concept is that in a virtual private cloud, you do not have a public IP address to begin with unless you ask for it. There is a gateway available. So something like Comcast, imagine this is your home. So imagine this is your home. Simplest way to think of is your home. And you have a Comcast, unfortunately, Comcast connection, and that will basically give you a modem, cable modem, and then you will put your router somewhere here in the home. This modem is almost on the edge of the home. And then you have a router. That is where the IP begins. And this location is actually a public IP that you obtain from this company. They give you a public IP address for your home. It is still in the public area. Now, inside the internal parts of the router, you might have multiple ways of connecting your laptop, your iPad, your TV, your media center, whatever you have. A bunch of other things like Xbox, God knows what. So each of these machines individually will have a private IP address. They are not public IP addresses. These guys do not have a public IP address. This guy has a public IP address. It's typically one IP address made available to every home, typically. Unless you have a dual WAN home scenario, dual WAN office scenario, like small business, or you're a gigantic corporation, that's a different story. But conceptually, this is what, at a bare bones, a VPC looks like, sort of looks like your home, which is secure from the world outside, and that you are safe because your machines internally cannot be accessed from things on the internet outside. Meaning, this bad guy who lives here, he is bad, let's say bad. This person cannot connect to your laptop through a remote desktop session, RDP, not possible. SSH to your media center, not possible. No, it doesn't work because there is no routable path to the internal private IP address. It is not a routable address. It is those RFC that I mentioned, RFC 1918 that I mentioned early on. So it is not possible to connect and route traffic to these guys because they're private. So that's the scenario. Now, let us understand what network topology is needed to build such a thing in a virtual private scenario, virtual private cloud scenario. The network topology that you need are, at the bare minimum, you need a public subnet and a private subnet. Public and private. And you need those two subnets, and you have to call them by these names to make it easy for us to remember what is what. You don't have to use these names. You can use whatever name you like. But I'm just using these names to make it easy for me to understand and remember that this is going to be a public subnet for me, which means any machine that I create here will get a public IP address. Any machine that I create here will not get a public IP address, will get only a private IP address. That's how you should think about when you ask for a machine from a cloud in a VPC or in a virtual network or in a firewall or whatever cloud company calls them, whatever names they use. Concept is this, that you have to have two distinctly different subnets, and you will ask for a machine to be placed in this versus that. That's the key distinction. By default, if you just say, give me a machine, you will get it here. Yes, that's where you will get it. If you don't say anything, it will give it to you right there. And that is a good thing because we don't want the machines to be on the public subnet. By default, they should go here. All of the machines should go to the private subnet. That's a good thing because you are protecting your private property from the bad guy.
So when we created ours on DigitalOcean, it created it as a private, and the IP address we got was given by DigitalOcean.
Yeah. So what did DigitalOcean do is, first thing, in DigitalOcean, they do not have a VPC, no such thing, no VPC. Which means they don't have this idea of a public and private. They don't have such a thing. There is no such concept of a public subnet and a private subnet. There is no such thing.
Okay, so they created a public.
Yeah, there is no such thing. All they have is this. So that means we are at risk already to begin with. Like, anything is already on the public internet. So bad guys can attack if they want to, which is bad. And that's why I don't recommend, unless you know what you're doing from a production deployment perspective, people don't go to DO. But still, DO is very popular among developers because it is very easy to test out scenarios. Like, I want to do this, try, delete, do it again, delete. Very easy, very convenient, and very affordable, and very high performing machines. They don't give you all the security cover, but then certain usage scenarios don't require them. So that's a great use case, especially when you're learning. Great use case. That's why I'm advocating for them, because I like it. It is cheap and it is fast. And it doesn't come in the way, and just quickly get to a point. Connect, boom, connected. Next, delete, deleted, move on. Right? That's great.
Side question.
Yes, please.
So I know you're a command line guy, but once we make that connection, or we create that server, right, machine, you can connect obviously via command line as we did, but can you also remote desktop in Unix directly from, say, our laptop into that now machine running on DigitalOcean?
Yes, you bring a very valid point, and I must tell you a new concept to answer this question. The concept is, in Windows land, I know it is very familiar to you, is known as let's remember the name.
Remote desktop?
No. The word I want to try to remember, it's called Windows Core. You know this word, core? Just the bare minimum operating system.
Yes,
that's what I'm talking about. The core, right? The Windows core. So on the Linux side,
The one that comes without UI.
Yes, exactly. So no UI. There is none. There is none to connect to see. There is nothing to see on the DigitalOcean or Amazon or Azure. By default, there is nothing to see. All you get is an operating system that doesn't even need to have a graphics adapter. Doesn't need to have a UI, because who cares? I mean, at least I don't care. So some people do. But for them, that's not the usage scenario. The concept that I'm now talking about is this. Is the concept I would like to call. So these two are conceptually similar things. So they're pretty much same thing. The idea that I would like to now talk about is the concept which I call juice, and I'll spell it for you. This is a key concept to think about and remember. Just enough operating system. What does that mean? It means just the basic kernel to get the machine running, the input-output running, the network traffic running, the CPU operational, and a method to invoke a command, a method to run some application, and the application doesn't even need to show me anything, as long as it works, does the number crunching, does IO traffic, does storage handling, does network traffic, anything that it needs to do, as long as it is doing it, that's the bare minimum thing I need. And one more thing, and that is Open SSH library. So add that, so I can at least connect to it, right? So these are the bare minimum things. So in Windows land, very similar concept. You will get Windows Core, let's call it W Core, and you don't use RDP. You use something known as WinRM, which does not have a UI. And not many people, even at Microsoft, use this. And that's unfortunate. But Windows has a similar technology to OpenSSH, known as WinRM, and it is very stable, very nicely done. But not many people actively use that window in Microsoft, even inside the company, because they are familiar with RDP. So they just expect a desktop, and that's good, and it works, and everything is fine. But it is resource intensive. I mean, not intensive, but it consumes non-zero resources. And if I can get away without spending CPU resource or some other graphic resource, I would rather not spend that resource. So I can cut RDP. And I would want to cut RDP because it costs money to run RDP, because my CPU need is expensive. I would rather use a cheapo $5 droplet as opposed to some expensive machine. So by the way, I want to delete this box. So here, so I'm deleting that. But I don't want to necessarily spend more money on a bigger box if I can get away with a smaller box. Why is that important? It saves me money. And I'm not talking about 0.007 cents, but multiply this by 20,000 machines, because I will scale, right? So I will save a ton of money on 20,000 machines deployed at $5 per droplet versus $10 per droplet. The amount of money I save is big. I mean, it's probably more than a latte, maybe a salary, a person's salary. So you can save a substantial amount if you are really doing large-scale deployments, and you are cutting down on unnecessary services that you really don't need. And that's the core idea. And that's where this concept of Windows Core comes along. That's where this concept of just enough operating system comes along. And let's go look at some examples. Here is Ubuntu operating system and the mini.iso. Let's see its size. So here is mini ISO. The entire ISO image from Ubuntu is 54 megabytes. Look at that. This is 64-bit Janial Xeros, 54-bit 1604, latest stable minimal system. You get a complete operating system that works in that size, and that is mind-boggling. You know, compare this with Windows. You will see it yourself. It is so tiny. It's a full operating system. So that is the beauty. So all these machines that people build up. So for example, let's go to DigitalOcean and look at their images available, and look at not these images, but yeah, these images. So these choices that they have. By the way, DigitalOcean does not have a Windows choice, just so you know. So, but we will get to another cloud that will have it. So here you have Ubuntu OS and FreeBSD OS and Fedora OS and Debian OS and Core OS and CentOS. So not many choices, very limited in terms of operating system selection. But these images are basically loaded up on top of a virtual machine. And that's what you end up getting when you sign up for a $5 droplet or a $20 or a bigger droplet. You're going to get a big chunk machine also, like 64 GB memory and 20 CPUs, and for $640 a month. That's also available. However, the amount of time it takes to boot up and start a complete machine with the image, including your authorized key embedded, is less than 55 seconds guaranteed. That is possible only if you keep the machine operating system image really, really small, to the barest possible minimum you can get away with, which is known as JEOS, juice.
Gotcha.
Just the minimum. So no concept of an RDP.
Right. So cloud computing essentially makes use then of the headless OS, if you will.
Yes. Headless is good, and therefore no UI. Right? And so you get away with the least amount of resource you want to spend on to get the most amount of extract the most output you can get. That's the approach that most cloud images are built out of. Even Windows images built like this with Core to begin with. Linux images built with mini ISO or some even smaller versions, but then added on only those components that are absolutely necessary and strictly nothing else. Strictly nothing else. So it reduces your footprint on the disk. It reduces your CPU requirement, disk requirement, IO requirement, network requirement. temperature, cooling requirement, and money requirement. So all of these things benefit and impact. That's the reason behind using of cloud, because it makes it efficient. And we will go deeper in actually building images, especially when it comes to Docker. You will see this clarity of how do you add exactly what you want and nothing more. Absolutely nothing more, to minimize the amount of space, amount of resource it takes to construct in a scenario where you are running your applications in a given context. And you will see that. Cool. So in this example, DO, it is scary, but just be aware, no VPC and no private subnet as designed by Microsoft, Amazon, Google. You will not find it here. So you are at risk already there. Now, in this scenario where we are talking about a picture where we are, let's get another sheet of paper. And now we are discussing this idea of a public subnet and a private subnet in the context of a virtual private cloud or a virtual network in Microsoft language, Azure language. And you are defining these two subnets very, very clearly, succinctly clear. And when you ask for a machine, they'll give you here. But if you ask them specifically, please give me at least one machine right here, and that's great. And you need to have at least one jump box right there. This is also known as bastion, or also known as tunnel. You can call it whatever you like. But that one machine is needed to be there on the only purpose that we will assign to that machine is to be able to jump. So we will connect from outside here through our public IP that is available on this subnet, and then jump to wherever we want to go. And this jump is a one hop with one intermediate and then next to the target that we want. So whatever target we have in mind, we can just go to that machine, do whatever we like, connect to it just like SSH, except the scenario is to be able to jump. Now, let us understand what does it take to construct these two subnets. So if you go to the Amazon, by the way, I'm assuming you have Amazon accounts also by now, which we discussed the last time. So if that's not the case, you should establish an account already. In fact, you should establish all these accounts for free. So Amazon, Google, Triton, DigitalOcean, Azure Cloud, all of these guys are giving you free access. So make use of it, open accounts there. But remember, don't leave machine running, otherwise you will get hit with a bill at some point. So remember to clean up after you're done. So you, just by giving a credit card doesn't happen, doesn't cost you anything. The free trial that they have will keep track of, and even in the free trial, even if you spend resources, they're still not going to charge you. But just be aware that it's a good thing to clean up after you're done. So open up accounts if you don't have any, but I'm going to just go to my account here in Amazon and illustrate this idea of a subnet. So if you, as you begin creating a machine in Amazon Cloud, you will go to the Elastic Compute Cloud, which is in the upper left corner, EC2 right there, Elastic Compute Cloud. So click, and here there is a button, the blue colored button, to launch an instance. An instance is basically a droplet or a machine or a God knows whatever, server, you call it whatever, but this is what it is. You get a virtual machine basically. So you launch an instance. And here we are going to launch some operating system, and my favorite is Ubuntu. So that's what I will take, Ubuntu server, and select. And here I will now select the size of this machine itself. Like in DigitalOcean, you had only these choices. In Amazon, you have a whole lot more choices, and we'll go through these choices. But for right now, I'm going to select some size, like M4 large is a good one, or M3 medium is also a good one. So we can select how many CPUs, how much RAM we have, and proceed. So I'm selecting M3 medium, which gets me an SSD, and it's moderate performance on the network, and I will configure the details. When I configure the details on this account, on this particular unit, you will see some of the characteristics that I'm going to talk about. It says in number of instances needed, I just need one machine, so I'm just saying one. Next one, I will skip the purchasing option for right now, but I'll come to it later at some point. Network is the choice of which you can have multiple VPCs, by the way, multiple. There is no limit to it, practically no limit. So just like this is one VPC, you can have any number of VPCs in your account, no problem. And that's the selection that you have to actually do, is to select a VPC that you want to use. I have only one VPC, it seems, like this. And that is the VPC that you get by default when you open an account with Amazon in every region, like Virginia and all these guys. You will receive one default VPC by definition. So they give it to you, create it for you. And now a cautionary note. The caution note is, do not delete your default VPC by mistake. Do not delete. It is okay to delete other VPCs, but do not delete your default VPC. That's the caution. So you remember that. The workaround exists, but it involves a phone call with Amazon that they don't have a method to restore it on your own, and it takes a couple of days for them to bring your default VPC back. Until that time, your exercises and hands-on work may get stuck. And that's the impact. So with that understanding, the caution again, you can delete VPCs, but please do not delete your default VPC, default, the one that is given to you. If you create a new one, like I'm going to create a new one right now, by clicking this button to create a new VPC, that's okay to delete that one, no problem. Delete that, no issues. You can create another one, no problem. But the idea is to create a new VPC and use that VPC. So you have a machine created inside that VPC, and that's what we intend to do. So in this example, I will start a new VPC creation. So I will basically click this new VPC button right here and start a new VPC. And maybe I think it'll confuse many people who are new to the concept of VPC. So I don't want to go too much into complexity. I want to keep it simple for right now at the first run. We will go build our own VPC later by hand, by step. And by the way, there is a video series here in the dashboard. You will see it, which walks you through 1 minute short videos in 11 steps. So step by step, there is a pre-recorded videos already available that you want to see on your own at some point. I think it's module number 11. So this module 11 is what it is: data center in the cloud. You basically build your own data center in the cloud, build your own VPC in the cloud, step by step, by hand, without using automation, so that you really understand what's going on. And then later on, you can subsequently use automation. But right now, I'm going to not create a VPC, but just use the existing one that we have already. So we have one, and that is already selected. It is the default VPC as shown in the listing here. It says default, and its name is default do not use. That's my name. I've given it that name because I don't want me to use it. So it says default do not use, but that's okay. I'm going to use it for right now. And in here, I get to choose my subnet. And I have these subnets choices available. Let me adjust the screen size a little bit, and I'll focus on that in like this. Yeah. So here I see that these subnet choices are available to me, and I have a subnet default in 1E, 1A, 1C, and 1D. So I have 4 subnets. I can assign a machine in any of these subnets. Like this, I'm going to select 1A, for example, US East 1A. This is in Virginia. So I am in Virginia address apparently. So let me go and see at the top. Yes, I'm in Virginia. And so I am basically selecting one such subnet, which is going to be this subnet 1A. And in there, I'm going to say, give me a public IP, please. So I'm going to actually ask for a public IP. So automatically assign public IP, I'll say, please do that. And this is the first machine, the jump box I want to create. So I'm doing that right now. Next one is IAM role. I'm going to skip it for now. You don't need it at this moment. The shutdown behavior is to either stop the machine, which means the bill continues, or terminate the machine, which means the bill stops. So you understand the difference between terminate and stop. If you just stop the machine, shut down the machine, you still get a bill. You have to kill it with a machine gun. Then the bill stops. Terminate the machine. Then the bill stops. Until that time, you will get charged. So just remember that. You want to terminate the machine when you're done with it. Now, having said, when you shut down the machine, at that time, it can either stop the machine or kill itself. So that's the behavior choice you want to do. So when you shut it down, you may want to keep it alive for next instantiation or just rebooting. You want to stop it. Otherwise, if you select terminate, the machine will self-destruct. And you may want it in some cases, but right now I'm choosing to keep it as stop. I don't want to terminate it when I stop it or when I shut it down. Next one is some other choices. There are actually way too many choices in Amazon, and don't get scared. We'll focus on the key ones to begin with in the first attempt, and we'll go deeper in understanding the entire level of complexity, and we'll go repeat these exercises in other clouds like Amazon or Microsoft or Google or things of that nature. So that's why I need to have you accounts ready. And so the understanding that I will like to have you is enable termination protection is for security. Is, you cannot accidentally shoot yourself in the foot. If you want to protect termination, accidental termination, you can select that. You can enable monitoring. It costs more money, and we don't want to waste money. So no monitoring for right now. And you get a tenancy, which is either you run it on a shared hardware or run it dedicated. Dedicated means more money, and you don't want to waste money right now. So sharing is good. So you can actually select a machine to be dedicated on the hardware for you, which will cost more money, but just understand that that choice is available to you. Now here, my choice was to automatically assign a public IP, and that's what I'm going to do right now, right there. And now I will proceed forward to add some storage. Now in this storage segment, I can select to add a bad magnetic disk, which nobody does. Like there's this choice of volume type. There are three choices. Like I think I mentioned the last time, I'll go repeat that for us. The three choices that we have are bad disk, bad disk, which is magnetic. Let's call it bad. Don't use it. And there is a general purpose SSD, which is a good one default choice. And the second one is IOPS. You can specify how many IO per second you want. And this is a high performing SSD, not Hewlett Packard, high performing SSD. And that's a good choice. But it costs money, not $3, but maybe $50 more. So that's the pricing scenario. You can select, and you can select the size of the machine, size of the disk. That is 8 GB by default, but you can increase it, and you proceed forward. You can tag the instances if you like, giving it as a name, such as Cloud Genius is a good name, and proceed to configure security groups. Now, this idea is worthy of another discussion in a level of depth. So this is something very critical to understand, because this is the only way to get into the virtual area, the virtual private area. So this topic of security groups is a key aspect to understand, and I will spend more time on it next time, in fact. But right now, I'm just giving you a quick overview of what it means. It basically means firewall. Firewall translates to which traffic can go from A to B through which port and which protocol. So whether it is TCP or UDP, or which port number you want, and whether the traffic origin, the source, it originates from A and can it go to B. So that collection of rules around what is allowed and what is not allowed, a collection of those rules constitutes a firewall, basically. Firewall is implemented in Linux using IP tables. IP tables is an open source program available in multiple places. I think this is the manual page. So that's a fantastic program built into all Unixes and Linuxes. It is the native firewall. That is what is used by these cloud providers such as Amazon to construct this idea of a security group. IP tables is the underlying technology. Security groups basically are a collection of rules that will say, if the traffic originates from this source and wants to access this port number onto this area protected by the security group, and you allow this port, this protocol, that protocol, and that's it. So that's the kind of collection that we need to allow or disallow. Now, having understood that piece of simple idea of security groups, in our example, what we intend to do is from our laptop, we want to be able to connect to the tunnel or the bastion or the jump box. What is the name that I prefer? I prefer jump box. So I want to connect to that jump box, which has a public IP address. However, this box is inside a protected area, VPC. So even if I have a public IP that I know, it is not going to connect. Even if I have my private key and public key all in good shape, and it is in the tunnel bastion authorized keys listing, and I have the private key in my laptop, and I say connect, and I know the IP address, and I know the correct IP address, and I have a good connection to the internet, everything is okay, but still you cannot connect because firewall. VPC is surrounded by a firewall. Alligators. You cannot get in. That concept is security groups concept. And we need to explicitly open ports. What do we want to open? We want to say that I want to come from my laptop and I want to use the SSH software, which by the way uses port number 22 on TCP protocol. And this is my location. So this is my IP address, basically the source IP address. And from this source IP address, I want to use this software, this protocol, this port, and please let me in. Okay, allow. And this rule I need to construct and tell Amazon, hey Amazon, let me in. If you don't do this particular scenario, even if you have all the things in place, like you did for DigitalOcean, it will still not work if you don't have this critical thing, because this is about that firewall that I mentioned, the red line here. So let's construct this specific rule, which is from my IP address, which is this IP address, allow port number 22 access to TCP protocol inside the VPC. Please allow, please. And that request we have to include in this form. So you can very simply include that request by creating a new security group and calling it let me in to port, let me in via SSH. That's a good name, although it's hard to read. So let me in via SSH. That's the name I want to use. And I will make it a little bigger so you can see from a distance. So that's the name I want to choose for my security group. Let me in via SSH. That's just the name. Then I have to define the rules around it, which I will do. So I'll say, protocol to use SSH. Or I can say custom TCP rule and port number 22. That also works. The same thing. I can either say SSH like this, or I can say custom TCP rule port number 22. It's the same thing. I need to say that allow this traffic. So source can be anywhere. This anywhere means literally anywhere on the internet. And that anywhere is indicated by this CIDR notation. So some of you may be new to this notation, and we will talk about this at some point. But right now, the word cider is a good Google search, CIDR, and you can read about it in Classless Internet Domain Routing on Wikipedia. This is probably the best known write-up. Read this page, it's fairly long. I have a very short condensed version of this in my site. So there's a 1-minute video that you should watch in this listing somewhere here that talks about CIDR, and you should read that. Yeah, there it is. So unit number 3, module number 11, that's subnets and cider notation. There's a short video on that you should watch, and it should clarify. If it still doesn't clarify you, let's talk. But that's CIDR that basically here says in Amazon, allow anybody on anywhere on the internet to come in. Now that itself is a bad thing. I don't want people to come onto this machine from wherever they are. Even though they might have my private key, I still want to prevent them through firewall. So I'm going to say that this source should not be anywhere on the internet. I don't go anywhere outside my office. And whenever I want to connect to this machine, I will always be in the office. So please use only and limit it only to my office address. Only if I am in the office that you please let me in to connect via SSH. And so the source has to change to not anywhere, but to my IP. So when I say my IP, it automatically calculates my IP and divide 32, which basically pinpoints to this particular IP address in a cider notation. And we'll talk more about CIDR notation at some point, or you read that video that I said. And here, now the rule construction completes. And I can say that let me in via SSH is a good rule name. The description is also very simple. Let me in, and the protocol is TCP, port range is 22. You can define a range, and sources you can define to whatever you want. In my example, I'm choosing that I define the office IP address, like in this example. So what I'm going to do is hide myself. So you can see the button and the review launch button. That's the button I want to click now. But it's a good idea to remember to provide your public key to this cloud company, which we haven't done yet. And we might forget, but don't worry, Amazon will remind you. So as you review and launch, it says your instance is not eligible for free tier usage, whatever, don't show this to me again. And now I am ready to launch. So let's review. Ubuntu server, M3 medium, 3 ECU, 1 vCPU, some memory, some storage, moderate network performance, security group, let me in via SSH. And the protocol happens to be 22 port number and TCP, and the IP address is this office address, office IP address, and some storage and some tagging and all that. And now I'm ready to launch. But we still haven't given our public key to this company. So we will still launch it and see what happens. So if you do launch, in fact, older Amazon used to allow you to launch without giving a public key, and then people will struggle that I forgot to give my public key, now I cannot connect to my own machine, and that is true. If you don't give your public key to the company, they will not be able to inject it in the authorized keys file, and you are logged out. I mean, sorry, you have to kill the machine, terminate the machine. But these days, Amazon has improved. So when you launch the button, it says, okay, come on, bring your key. So it says, choose an existing key pair if you happen to have already from a last attempt, which I don't. So it says no key pair found. So I can then create a key pair like this, create a new key pair. But this is a academic question. It's not, it has no practical implications. It's mostly academic in discussion. The discussion is, in this example that you're looking at, the choice between Amazon creating a key pair for me and I'm creating my own key pair. That's the difference, right? The difference in these two is that if I choose the option that is currently selected in blue color, I'm basically trusting Amazon and letting them run the SSH keygen command and hoping that they don't keep the private key. Hoping. I know, I'm just joking. I know they don't keep the private key, but I'm just saying, right? It's a philosophical question. And since I said just a few hour, half an hour, 2 hours ago, that never ever share your private key. So I am philosophically against this idea of letting anybody else create a private public key pair for me. Although if you do it, I'm pretty sure they don't keep the private key. But since I will be contradicting myself when I said, don't let other people touch your private key, that's a bad thing. So I'm not going to select the blue highlight button because that contradicts what I said early on. So the only other choice is proceed without a key pair, which is a bad choice. So what do I do now? So I will cancel out on here and actually go to a new tab where I will open the Amazon console and have another way to provide my public key to them. In a separate tab, open up EC2 console, go to the area where there is key pair reference right there. So click, and here, instead of asking Amazon to create a key pair for me, I will import my key pair. And when I import, I can literally paste the content ID_RSA and paste the public key right there by copying it from here, like taking my public key like this, copying it and pasting it. So this is the key that I want Amazon to use. So I know that this is the key I want them to import from me, as opposed to giving me the public and private key and keeping the public with them. So I will like to do this differently, my way, which is never ever give private key to anybody. That obviously the corollary is to not let anybody create a key for me. Because if they are creating it, that's a philosophical question. I know they don't keep the private key. I'm pretty sure. Now I import. When I import, the key becomes available in my listing in there, the list of keys. So this is the key that they have, the public, and I have the private. Good. I will close this tab now and go back to the other tab that I had open, which is this one. And now resume. When I say launch again, it says, yeah, there is an existing key pair. I can choose that key pair if I want to, or create a new pair, ask Amazon to create one for me, but that's not what I want to do. So I will just use the existing key pair that I now know, and I will acknowledge that I have the corresponding private key pair, private key file with me. So I acknowledge that and then launch. So when I launch, it launches. And I can see those instances are initializing. As you will notice, Amazon is a little slower compared to DigitalOcean. So it takes time, but should be slightly more than a minute and should be ready. This status check should finish and you will get an IP address assigned. And you should see that the IP address, public IP address, will show up right here. And we will grab that. The private IP address is already assigned, but that is not routable. We cannot go there. It's private here. The public IP got assigned, so I'm going to copy that public IP and go to the terminal. In the terminal, I will remember to check the location I have currently, which is pwd, which is the location that is .ssh. That is not the location I want to work on, so I will adjust cd tilde. And here is my home. So in the home, I will I'm still connected to the whatever machine. Okay, fine, close it. So close that machine out. And this is the terminal that I want to use. I have my IP address with me. And the command is slightly different, very, very slightly different, because the username is different. It is not root. So the command structure is very simple: SSH, then followed by -I, followed by my reference to the private key, and then the username at IP address. in the context of Amazon machines, the username for an Ubuntu operating system is Ubuntu, followed by IP address. That's the construct. That's the syntax. So same thing, SSH-I, private key, username at IP address. Very, very similar. And I will enter. Here we go. So it says, do you know what you're doing? And I say, yeah, I know. And so we say, okay. So it will connect and let us in, because we have the security group also open. And so we just connected, and that is good. I'm going to exit and now go back to that security group, which is somewhere here. There, security groups. And I have this security group called Let Me In Via SSH. Right? That security group I want to modify now. And I will shoot myself in the foot right now by disabling the location, or just editing the inbound route and saying edit, and say, you know what, no SSH for you. Boom. So I killed myself. I cannot get in now. Although I have the group doesn't have any rule. I deleted the rule. So there are no rules in this group. So they let me in via SSH. That rule exists, but it doesn't have any entity. There are no rule elements in the group, in that security group. So that means I cannot connect to this machine myself anymore. And I can prove it to you. Here it goes. I just ran the same command and it will wait forever. Ever. It is not going to find any route to reach inside that virtual private cloud, even though I know I just connected, because the security group locks me out. Now I'll go back to the security group and modify it again and say, you know what, SSH, please allow me from my IP address and save. And you come here, and in a few seconds, or maybe in a second attempt, you should find that it is routable. So yeah, I connected. Boom, it connected. So that lock was available as a perimeter firewall around my entire configuration. So this entire perimeter.
And there's no timeout.
Yeah, it did not time out because I was quick enough to go and update the records.
Okay, so it will time out.
It will time out eventually.
Okay.
So yeah, it will eventually time out, but I was quick enough to go and update, and so it responded in time. And so now we are connected. The scenario essentially is that it is different from what you saw in DigitalOcean, is that in DO, it was, a jungle, jungle as in public IP. In here, even though it is public IP, it is still protected from a firewall around it. And that firewall is regulated through this construct known as security group. It's also known as virtual network in Azure, and firewall as a name in Google Cloud. And so a bunch of other companies call it different things, but the concept is same. They all use the same kind of concept, which basically this, you have to have a source location defined from where will you originate the traffic, which protocol will you use, TCP, UDP, and which port you want to connect to. And that's the collection of rules that constitute together a collection known as security group or virtual network that applies to a collection of machines that will follow that discipline and allow or disallow access. So we'll go more on this context as we go along in our deep dive. So what I would like you to do as we meet Saturday morning is a couple of things. First thing first, please open that accounts on all the free accounts that we have. So just have an account there. Doesn't hurt at all. Remember, if you start a machine, you're doing something, great, do it. After you're done with it, remember to kill it, terminate it, destroy it, whatever other words people use. So some companies use the word destroy, other companies will use terminate, other companies will use the word delete. All these things mean the same thing. Stop does not stop the bill. Remember that. Stop does not stop the bill. So create accounts. that will help us in understanding the deeper discussion we want to have next, which is in the aspect of infrastructure as a service. And when you say infrastructure, you should read on the videos that I have written down and some material, is the idea. There are three things primarily, actually. So the three things are compute, storage, and network. In fact, you can practically assign some kind of a structure, whether it is compute heavy, storage heavy, or network heavy activity that you need from the underlying application. And accordingly, you will select the appropriate type of machine, the size of the machine. Sometimes there are other characteristics, but these three are most commonly used. I will now briefly mention those other characteristics that are also important, and those are from an infrastructure as a service perspective, which is where we are going down deeper. And so we mentioned CPU, storage, and network. There are a couple other variations to these that are also important, and those are GPU. You can have graphical processing unit. That does not mean that you have a display, no, but that it means that you have special math capability to do number crunching. So number crunching is what is useful, and you can use GPUs for this. And so there are some types of machines and some type of applications that are very nicely suited and work very well if you have a ton of GPU, even though you don't have a display. An example is Bitcoin. You need high GPU power, not too much CPU, but mostly GPU power to mint Bitcoin. That's one example. There are more mathematical examples that require number crunching that are best done in GPU arithmetic as opposed to CPU. So that's a resource type. Another type of resource that is important is how big your storage is, size, it's big or small. And another characteristic that is important in the concept of storage is how fast it is. Is it slow or fast? Meaning, can it handle I/O per second decently or not? Now that's the storage related aspect. In the network context, there are two characteristics. One is the bandwidth available. How big, how small, how wide, or how narrow. That's the right way to say it. Wide or narrow, narrow band, wide band. And the second thing that is important is latency. Is it low or high? And those characteristics generally constitute all the important sets that we need to worry about in infrastructure as a service. And we will understand these things and go detail with examples. We'll play scenarios, and we'll also do this next logical step, which we did not do today, which is to be able to jump through the jump box that I just created. And so I have this jump box that is running right now. I want to terminate it. So I will basically right click on it and say instant state and then terminate. So it's difficult to look for it. It's not easy to find, but remember, instant state, terminate. That's how you kill it. And you say yes, and you destroy the machine that you're done doing whatever you're doing. The machine goes away, your bill stops. That's that you need to remember this. So next time we will go deeper in the infrastructure elements. You should read this section here, at least this aspect of let's say. So you should read modules 1, 2, 3, and 6. Yeah, 1, 2, 3, 6. That's what I think you should read those things. And so 1, 2, 3, 6. Those modules you should prepare ahead of time, and we will go deeper in the aspect of understanding infrastructure as a service with a variety of cloud companies, IaaS, and we'll spend quite a bit of time. We'll design our own VPC by hand. through clicks on the Amazon dashboard, understanding each and every concept needed to make it build just like the way we want. We'll also then go into, at subsequent time, spend some amount of time in what is known as software as a service. So this idea is very simple. You probably already know it. You use it. We are using it right now. We are using this software to do a streaming media broadcast to you. We are using OneNote application connected to a SharePoint service run by Office 365 in Microsoft. And so tons of services we already make use of. And I think there is not much to really learn as to what software as a service is, because it is trivially intuitive to most of us. The next thing which bridges this and this is kind of complex to understand. And that is the idea of a platform as a service. So we'll do hands-on exercises on that as well. There's not much to do hands-on. We are already doing it hands-on on software as a service every day. You work at work and I'm here and we are doing it. So not much, we'll spend not much time on this aspect unless you want us to. And we'll go deeper in this angle as well in understanding platforms as a service. Take an example application, run it in a platform, Heroku platform, for example. And then we will have another open source platform as a service, which I think is of interest to at least a few people in Boeing that I know, because they're deploying a platform internally known as Cloud Foundry. So this is another open source project. Cloud Foundry is sponsored by EMC, but it is open source. And this is the application that Boeing is running internally. It is an open source platform as a service. Now, this is a fairly elaborate thing to actually pull off, and it is not suited for a classroom live demonstration. So we have another smaller platform as a service that I will demonstrate, and we have an exercise on this, and that is this DAYS platform as a service, which is another open source project available on GitHub right in this location. And we will go to GitHub, grab it from here, run it on some cloud, and understand what is a platform as a service, how do we run our own, and then take an example application and run it on our own platform as a service, which will run on some infrastructure as a service under the hood. So we'll have infrastructure layer. We will take this DAYS pass on top, run it, and then take another example application and run it on top of the platform to understand all these layers and see how our developers in our company can make use of this infrastructure and the underlying platform as a service that we can make use of and make it available to people in the company or who are our customers, depending on our usage scenario. But this Cloud Foundry is a fairly elaborate, intense operation. I cannot pull it off in a 3-hour session. So that's why we have a smaller platform, which is also, get through all the concepts that we have. So I think that's important. But in practice, I know Boeing is running this as a project. So if you are a Boeing employee, you should find out if you're interested and learn internally. And you're welcome to bring questions if you have. But there is no exercise that we will be doing with Cloud Foundry. We will instead do this exercise for DAYS. It's a different, similar platform as a service. There are many more such platforms available. And we'll also, Docker is another platform. We'll use it quite a bit in subsequent sections. Number 2 and 3, the DevOps and architecture, we'll have tons of exercises there as well. Microsoft has announced a Docker support. So you should internally try that out. I know I have a preview access from Microsoft. Microsoft Docker is coming out. Docker traditionally did not include Windows, but now it does. I mean, it doesn't include, but it's a offer available from Microsoft to run Docker containers in Windows. And that is available. There is a partnership and a preview product available that you want to use, and internal people already have access. So go play with it. You have it. I can connect you with the people if you're interested internally. I know them. So you should talk to them if you're interested in learning Docker on Windows. It is beautiful. And I am running it right here. As you can see, Docker is running. So on the Mac, it runs through this application that has been released a couple of months ago. It is not native to Mac, but it is now available. Similarly, it is also available on your laptops on Windows. I don't have a demo right now going, otherwise I can connect to that Windows machine I have there and remote desktop to show you Docker running on Windows, and it works just fine. You should absolutely play with it if you're interested. Docker on Windows is available in stable form, Docker Windows 10. You should get this, install Docker for Windows. So that should work. Again, do not run it on a Boeing issued laptop. It is okay to run it on, check with your Microsoft, check with your employer. Why should I tell? Go ask your employer, can I run this software, and then run it. Otherwise, it is better to run these applications on your personal computers at home that you spend money on, and that should be okay. It is probably not in the Boeing software library, so don't worry about it. Use your personal laptop and play with it. So this is where you get Docker for Mac and Docker for Windows, the same location, you have both. You should try on your own, and we will do more exercises on this, but our usage of Docker is going to be in here. And this thing has Docker already installed. So, you don't need to actually install Docker on your Windows laptop because Docker is right here. And it is not, Docker images. There is nothing done. It's a fresh, brand new machine, but Docker is installed. So you can use it. There's nothing else no exercise is done yet. So that's why it doesn't show you anything as such when you run the command. It's empty because it's a clean slate. So you have the opportunity to play right here. There is Ansible, there is Chef. All the tools you can imagine are already preloaded. And so you don't have to worry about installation steps. They're taken care of. Okay. And with that, we meet again on Saturday, which is 17th. So we meet again at that time. It will be early in the morning, 8 o'clock, as you know already. It is not super early, but that's the time. So I hope you know that. The timing is not evening, but Saturday morning. Repeat, 8 o'clock in the morning, Saturday. Cool. Any questions?
Thanks, Nilesh.
Thank you, sir. Thank you.
Thanks, Nilesh. Just one curious question.
Yeah, go ahead.
This cloud services that they're providing, do they do multi-region services? Like if you want your servers in Puget Sound and then East Coast and West Coast like that. So
Yeah.
can you have those kind of service and communicate between those two?
When you have an application, you want to run one leg here and other leg there, that becomes a design consideration. So you have to have the application should tolerate that. Okay. So you have to have a method of replicating your databases and replicating your storage, and that's an application design consideration. But yes, possible.
More on like my question was on the network level. So on IIS level, will they give you like that kind of a network bandwidth if you want to?
No, they don't. You have to spend money over it. You have to spend money for it. Yes.
Okay, got it. Thanks.
Yeah. It is possible to buy bandwidth, but it becomes very expensive. Only big companies can afford. Like Boeing can, but I don't think I can, honestly.
No, I know. Got it. Thanks.
Yes.
So, Naresh, Dennis here.
Yeah, hi.
Yeah, can you help me out a little bit? I would like to get my dashboard, to log in.
So hold on. What I'll do is I'll stop recording because otherwise the recording becomes long for no reason. So let's stop recording and we'll continue our discussion, okay?
All right.
So give me a second.
All right. Thanks, Nilesh.
Yeah, you're welcome, sir. I have stopped recording and you are welcome to share your screen if you like.
Sure. Just one sec. Share screens. No, where's it? Okay, here we go. Share screen.